Oh, it said recording in progress. Perfect.
Is your mic still on, maybe?
We got it.
John, I think your mic's still on. Okay, I turned it off, or you turn it off, maybe. It's off now. Oh, I'm good. No, I'm fine. I'm fine. Thank you.
David, I think we did it.
All right. Let me see this. Ask all the new musicians. All right.
Unfortunately, Connie, who's the one that knows a lot about Miwoks, is in Hawaii right now.
Oh, unfortunately.
So I go, I don't think if I'm on hold, I don't think I can get on. Well, do I have, yeah, I have to be on because I'm recording. Could you monitor to make sure that I'm showing what he's showing?
You mean go between?
Yeah, so you'd have to sit next, looking over David's shoulder.
Well, but you'll see on the screen.
Yeah, but he wants to make sure it's on the screen. You know.
Yeah, I'll see if it's not on the screen. Yeah.
You can see.
Yeah.
You'll monitor?
Yeah, sure. Yeah, yeah.
Oh, yet another thing.
And then you can see here.
So everyone online, do you see my slides there? It should be full window, the peopling of the Americas.
Yes.
Yeah.
It's great.
Okay. Fantastic.
Oh, you got it. Okay.
And then for the four of us, and then we got, this is, I'm gonna be ecstatic here. So very good. We got this working. We got five people in our living room, and it looks like we've got 5, 6 people. So we've got a quorum. So take it away, David.
John, I'm going to interrupt you. This is Carol. Right now, I'm seeing the presenter view, not the, so I'm seeing your notes on the side. So I switched from David's screen.
Okay, let's see if we can change that. So I think you have yours. I only share again if that makes a difference. Does that make any difference there?
No, I've still got all the screen on the side.
Oh, this is the problem we have.
The slides.
I think it's, I'm sharing.
Now I'm, yeah, now I'm
Says you're
back.
sharing screen. So maybe you
Whoever it
you
is.
see it?
Yeah, now it's the way you.
It says the peopling of the Americas.
That's right. That's it.
Okay,
And back to what you
fantastic.
had
How did
before.
you fix it?
I just went to full screen. So
Oh, okay.
rather than it sharing the little screen, I guess.
Oh.
So we're all good, right?
Yep, looks great.
Okay, well, let me try to do this so you guys get this weird view of me. Let's see, it's been the last time I went full screen on Zoom, I was, well, not too long ago actually, but the last one I was lecturing at St. Mary's. So I guess we're good to go, huh, guys? Thank you to everyone that's here in person. I appreciate everyone showing up. Everyone online, of course. I appreciate you guys coming back for the second round. That means the last round wasn't too exhausting or jumbled and inconsistent. So let's just check on a few things real quickly. So I'm going to go ahead a few screens. So John, here, if we can go ahead again to the screen that says Panthera here. Okay, so that's not advancing here yet.
I got it.
Okay. 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 Is your are you muted on there on the recording? Just so we have. Here, I think you are now. I think you're muted now because I just don't want to get feedback on the recording there. So I just want to re-highlight some of the examples that we brought up before because it is relevant to what we'll look at when talking about human colonization of the Americas. So remember from last time we had these examples of Panthera and of mammoth, and then of Canis lupus as well. And the reason to show you guys these slides and just to remind you again is to reiterate that as we saw, there are multiple glacial and interglacial cycles, and therefore there are multiple intercontinental exchanges between East Asia and North America. And that's important with some of the stuff we'll look at. So again, this kind of idea that there's one shot, it's basically at the end of the Pleistocene, the end of the last ice age, and that's when the humans come in, and that's when a lot of the fauna comes in. I mean, that's not true. Obviously, there's many periods of that kind of intercontinental exchange between the Old World and North America, and then exchange between North and South America as well. So I just want to emphasize that. And then we'll advance again here, John, back here on the home front to our slide where we left off on the first one saying coasting out of Africa. So we're trying to manage two different screens here for everybody online so we can see. The first one that says coasting out of Africa, and there's a bunch of pictures of skulls on it. It's the map of the Old World and a bunch of skulls. There's so many slides. I'll go check. Yep, that one. Yep, exactly. Okay, so this is kind of where we left off before. So if you remember the grand narrative, we looked at some of the archaeological evidence, particularly from South Africa, and highlighted that there was some potential indications for similar kinds of what's called behaviorally modern culture, particularly behaviorally modern or symbolically mediated material culture, right? So the idea that language and complex agreed upon social practices that are really within a kind of symbolic framework, of course, language being in your previous sessions. I think maybe you may have, right? So you can think of it in that kind of Peircean perspective. It's one particular take in regards to language that people dealing with behavioral evolution and paleoanthropology particularly like to use, though it's by no means, you know, the sole perspective on the evolution of language, but it's one that works because we're trying to tie languages to material culture. Therefore, semiotics is helpful. I think it's a helpful heuristic. I don't know if it has powerful explanatory causal capacity, right? But it is a useful heuristic. So that's what we saw, right? That's the traditional narrative. We have the anatomically modern humans, and then starting around what we call MIS3, so the failed interglacial before the last glacial maximum, you have this emergence of behaviorally modern modern behavior. And then, as I said, that gets to this model of coasting out of Africa. And just to, the reason why I highlight this is if you remember from our last presentation, I said that there are models that come about that are brilliant in as much as the models compensate for the lack of evidence in the models themselves, right? So in regards to the missing or contradictory evidence, the model attempts kind of a priori, well, actually it's posteriori actually, because they understand the deficits, but from the beginning, they try to address the lack of evidence. And one of the reasons for that is, and this is what I wanted to get you guys to understand, that there is just a confusion of evidence, right? So we have a very large geographic space, literally all of the old world. We do understand that there's a period in which anatomically modern humans as a discrete population seem to emerge. And then by the end of the last glacial maximum, if not right before, it would appear as if this population dominates, right? So this phenotype. So you can kind of think of it, if you want to, more as a phenotype, although traditionally it's seen as a phenotype and a genotype. So a discrete species, right, being the genotype. In reality, what we're looking at doesn't mean we're not looking at the genotype, but in reality, we're looking at a phenotype. So a way of looking, right? Oh, so physical characteristics. And the funny thing is that even on this map here, which isn't that old, you have Cayo, I guess. I think that's supposed to be Spanish, and that would be, or Callao, my terrible pronunciation of the Spanish, but in the Philippines there. And for everyone on Zoom, I apologize, I have to point here, but if you see the star where the Philippines are, and you'll see that date there, which is 70,000 years before present. So this map is supposed to be showing you, until quite recently, what was assumed to be potential bits and pieces of anatomically modern human skeletal remains, very old across the globe, and particularly throughout Southeast Asia and East Asia. And like the material that is highlighted in East Asia, particularly in China, the material from the Philippines has recently been reconsidered. I mean, within 2019, for example, with the material from the Philippines. So to begin with, the site is recently, the skeletal materials recently been discovered, I think 2017 to 2018, at least by 2018, some information came out. The teeth from this specimen, it's actually now called the Luzonensis. The teeth appeared to look like it was from modern humans. So dental morphology is used quite a bit in paleontology in general, and then therefore in human paleontology to assess differences between species, and be a little problematic depending on who you talk to when trying to assess differences between anatomically modern humans and late surviving archaic humans. So as a full analysis of the skeletal material came out, of which there's a good amount, there's not just teeth. Oftentimes there are just teeth at sites. People think about cremation and so forth. It's the same kind of process. Teeth are far more robust, so teeth preserve longer. In this case, we are fortunate that there's a lot more than just the teeth. And as it would seem, this is not a modern human. This is another species of archaic Homo. So Homo luzonensis, that is perhaps related to Denisovans and Neanderthals, very late surviving. So again, that's to kind of give you this picture of how jumbled this information is. So even the evidence that's been put forth as key indicators of this human population expanding across the globe, particularly around this 70 to 50,000 years before present, some of that has been reconsidered. Other material that was considered to be archaic is being reconsidered too, and argued to be modern human. A good example is, well, actually, we'll see it on the next map, actually, but there's early material we've talked about before from Morocco, which was always considered to be archaic, and it's very old, 300,000 years old, and now the argument is actually this is a very, very early form of Homo sapien, right? So, yeah.
So I just realized with our setup, the audio. So because I'm recording it there, it's using my mic.
It shouldn't be. It should be recording me too. It should be.
It should be recording you.
Yeah, because it's recording that window. It should be recording everything that's happening over Zoom. It should be, but you can try. We can stop for a second and listen.
No.
Yeah.
You're booming.
Okay. All right. So Uh, Sorry, guys. So this is where we are. So my point is there's a bunch of confusion. We have a bunch of material all over the map. We seem to, for sure, it's not disputed that there are modern humans in Australia, maybe 45,000 years before present, right? So that leads to this kind of coasting out of Africa argument, right? Highlight where we will look at in just a few moments here.
You froze.
South Africa, not long before humans show up in Australia. And we, of course, want these humans in Australia to be fully modern human, right? Because if they aren't fully modern human, then we kind of get back into some arguments that are unfortunately exist in the history of the field, exist in the history of, well, European colonization, which is, people arguing both from a political and then from a scientific perspective that people, particularly Australian Aboriginals and other people from Papua New Guinea, are inferior, are less than, less evolved, and so forth, right? So I think for me, what you're seeing is a lot of different researchers in the field, some with very dominant voices who have a lot of money and some compelling narratives, because it creates a nice story about what it means to be human and when humans emerge, run up against this problem, which is they don't want to say that humans, even though as we saw before, we have anatomically modern humans at least 300,000 years ago, right? But they want to say we're not behaviorally modern, therefore we're not us really in any appreciable sense till about 55,000 years ago, really, right? With the Howisson's port. The problem being we have people in Australia at least that old, right? Or close to that. So what's the simple solution? The simple solution is, oh, well, we know that migrating by coastline and having a seafaring technology gets you from point A to B very quickly. And we don't need to deal with traditional demographic diffusion models, right? Because if we're looking at population density and we're looking at traditional species expansion into novel environments, that's a slow process normally, right? Although estimates vary widely, but it would seem to be a slow process. And the other, yeah.
Does that mean like there's one old? So do you think they came by boat, or like all those above them, Tampa and the Tankeri are kind of new, and Darikor is new, and so does that mean that they just didn't find any?
This is a map. Well, this is a map that's just.
I'll repeat the question.
Okay. Repeat the question.
Because they won't hear.
Oh, okay. So you're asking on specific examples when we're looking particularly at East Asia and Southeast Asia, we have material at 120,000 years old, as noted on this map. We have some, material in Northern India at 75,000, but if we look at Central Asia, it's 30, right? And so I think the reason why I showed this map was actually, and thank you for the question, but not to get into the fine details of it, just to show that there's a confusion of data. And what I think that we actually are looking at, in my opinion, is the older material actually isn't modern human, in my opinion. I think that we have an incomplete fossil record, and we have people who are overzealous and wanting to put their landmark, put their flag on their landscape about where modern humans are, right? Because what really funding bodies are interested in is the narrative about what it means to be us right now. And that's why there's this interesting process in which some of the earliest research, going back to Australopithecines, and particularly Australopithecines to early Homo, gets a lot of research, because you could at least say, aha, for sure, this is us. We're telling something about us today, right? And then there's kind of a lot of, let's say, there's a lot of funding that goes into everything in the middle, but it's been described as a muddle in the middle because it is a muddle in the middle. And you can't definitively say, unless you can demonstrate that you have anatomically modern skeletal material and your argument that you have modern material culture showing behavioral modernity, then it's difficult to say that this is for sure us and we're telling a story about us. Because you could always say you're not telling a story about us, you're telling a story about a sister taxon. Now, telling a story about a sister taxon, you can always relate back and say it's an alternative or near evolutionary trajectory, and we can say something about who we are, but it's more difficult. You get less funding. I mean, all of this is funding, and particularly with the need for two things. One that's always existed with NSF, which is, your research has to lead to something applicable. So it needs to have real world implications that benefit us economically or socially or politically. Normally the preference being economically, and it's difficult to show how this can be, but some, new advanced research in a physics lab, or particularly in a like a lab that focuses on biochemistry, that's why they get millions of dollars for to make one machine, to make one instrument. So archaeologists are lucky, even on huge projects that do end up on PBS and on National Geographic, to get $1 million or $2 million for the whole project, not to make one instrument in one lab, right? So that's a big part of it. So that would be my explanation of why there's a push. And there's another thing that I'm actually tempted to write an article on, although more people are writing articles on this kind of political process that is happening. But the PRC, like the Chinese mainland government, has become a significant funder in archaeological research, period. And particularly maritime research, but research in general. And a big part of that, again, is to, well, kind of sinicize, but to make, to the map as a major player in human evolutionary studies, right? So, of course, at one point, which we kind of talked about in my first presentation on the, East-West divide, Java and Java man and Peking man were very important skeletal, evidence, fossil evidence for the evolution of man, right? And that material is old. I mean, it is important. It still is important, but it's no longer looked at as a reference for what it really looks like to see an evolutionary trajectory towards us, which is what it was originally argued to demonstrate. Now it's seen and argued to be a secondary offshoot. So a lot of times people now separate ergaster and erectus. This is just getting further down the rabbit hole, but basically you have erectus first. That's description of Homo erectus. For sure, the type specimen is Java man. It's the triennial specimen that defines one of the earliest widespread members of our genus. So with that definition of erectus, you then looked at African material and saw stuff as old and originally classified it as erectus. But because there are some very minimal differences in cranial morphology, for the most part, there's a new term that starts to emerge in the 70s, which is Homo ergaster versus Homo erectus, to separate off the East and Southeast Asian specimens as a separate species, although ironically they come in to define kind of early human populations in general, and then make a neat pathway of ergaster, right? Ergaster leads to heidelbergensis, leads to modern humans. Erectus is replaced. Erectus is a side story, in the history of human evolution. Then we get into the 2000s and teens, and China drops a lot lot of money into research, and not too surprisingly, they claim that they start to find early modern humans in China far earlier than you do anywhere else besides the Near East, besides the Levant, right? So while we have some examples of early modern humans potentially at 120,000 years ago, more like 90,000 years ago in Jordan and Israel, the Chinese came out and said, no, we have examples of modern humans. And again, maybe this is the problem, So to get back to the original point that I was trying to show is, why is it coasting out of Africa? And we've got to go ahead here, actually two slides. Sorry, there's one in between, but that one doesn't matter. So the next slide here for back at home. So like, why do we need to do this? Well, the reason we need to do this, I said, is twofold. One is people want to have the first behaviorally modern humans in South Africa and some parts of East Africa, starting really around 55,000 years ago, really in place, or 55, really in place 50,000 years ago. But then we have anatomically modern humans essentially at the same age. The skeletal material in Australia, you're really fudging it to say that it's 45,000. Some of it's probably more like 65 maybe, or 60. I mean, maybe 45, but probably somewhere in between, probably 50,000. So you want this co-occurrence. So one, you need to get people from point A to point B. It's going to take a long time for populations to naturally expand terrestrially. We can model this, and we know it takes some time. And then the second problem being that the old world is already pretty darn well populated with archaic hominins at this time. So while everyone's saying, oh, we see modern humans popping up here and there, and maybe they are. Again, this is my point. The data is confusing. So I always say they're popping up here and there. This is a time period in which we have the best evidence for archaic human populations. So while we say Neanderthals, for example, first emerged as a discrete population 300,000 years ago, the bulk of Neanderthal skeletal material occurs within basically 65 to 43,000 years before present, right? So all in this time range. So if we're going to talk about modern humans expanding rapidly, right? So let's say the most kind of rapid terrestrial species expanse into novel environments that one could imagine, which could be pretty quick. There have been some models that suggest that North America, for example, could go from being, zero population to a population of maybe, 0.04 or 0.5 people across all of North America. That means the whole thing. So the parts of Canada that aren't under ice all the way into Mexico within 1,000 to 2,000 years, right? So pretty quick, right? Okay, so it could be quick. I think that's the quickest model you could think of. And I think it's kind of, I think the constraints in that model are naive. It's just a simple, how many people can reproduce with a small population over time and continue to expand. It doesn't take into account any environmental obstacles and so forth. So beyond that, this population, this area, is inhabited with archaic humans, and they're still there, right? So that's a big obstacle. Yeah.
So what's the water level at 120,000 years ago? Would it be easier to get to Australia with
So 120,000 years ago, the water level would be just the 120,000 years ago. I hate saying it this way. The water level will be a little higher. I hate saying that because it's not exactly what the right terminology is, but yes, the water level would be a little higher 120,000 years ago. So 120,000 years ago is the Evian. And so it's the last kind of true interglacial. We're kind of seemingly in a true interglacial. So MIS3, like we talked about, is supposed to be an interglacial. It seems to fail, particularly in the North Atlantic, right? So you don't have a proper retraction of the ice sheet in the North Atlantic during MIS3, although it's pretty nice in other parts of the planet potentially. I actually just saw a very interesting presentation today from a conference a few years ago, but a planetary, science conference that was looking at salination, and I mean, this is how boring my life is. Looking at levels this always been the case. And when you look at their models for the LGM, and we were talking about this before, it would appear as if Beringia, the waters around Beringia, were actually warmer, potentially warmer. So either the same, more likely than not warmer during the LGM, during the last glacial maximum, in which the North Atlantic, the ice sheet comes all the way down to Virginia. It comes all the way down to the Bay of Biscay in France. And yet, where the Aleutian Islands are today, it would be warmer, right? The sea temperature, at least, would be warmer. So kind of interesting, effect here. So these are some of these different things we're talking about. So at 120,000 years ago, it's the Eemian. Sea levels are actually a little bit higher. As we get into MIS 4, temperature drops dramatically. How much? I mean, for sure, you would have had slowly the reemergence of the Sunderland, right? So if we remember, and I don't want to flip this around too much here, but from our, if anyone wants to go back and look at the GIF that shows us, this animation of the, glacial interglacial cycles, right? It's really supposed to show us the last LGM to about 50 years into the future from now. But the reason why I use that is that really shows us what the change is back and forth between the Eemian and now, right? Because 50 years from now is kind of like the height of the Eemian, kind of, right? As far as the projection of how warm it will be, and the kind of, reduction in glaciers and the, rise in sea level, right? So not horrifically dramatic, but, a little bit. So if you look at that GIF again, you'll see that Sunderland, which is Southeast Asia, is a submerged subcontinent. And after, really even starting around maybe 80,000 years ago, so before the Eemian is over, before the interglacial period is over, you should start to have this greater expanse as there's increased glaciation. Although glaciation isn't as great necessarily during MIS 4, it's cold, but it's drier. It's cold and it's drier and it's quick. And then there's some amelioration in between. So what would this have looked like at 55,000 years ago? It wouldn't have looked like this. And that's the important thing, right? So we wouldn't have what's called insular Southeast Asia. We wouldn't have these islands. So Java and Borneo would be connected. Then they would be connected with Sumatra and connected to the Malay Peninsula. So people could walk. So that's important. That's important for the coasting model, because what it means is the assumption is people are really coasting. So you do need some seafaring vessels, but you are hugging the coast. But in this whole journey, there are periods where you are reaching or crossing trenches, where you are technically crossing deep water, even if you are coasting, right? And so that's that model. So I'm giving you the two different reasons as to why there is. And the model exists really because there's a confusion of data, not because there's compelling evidence for coasting out of Africa, right? There's not compelling evidence. There's confusion of evidence. People hypothesize a model that accounts for the confusion of evidence and the lack of evidence, right? That's just my point. And so again, don't trust what you see on PBS or National Geographic, basically, because I guarantee you coasting out of Africa is something that you can see on PBS. So we'll go to the next slide. And I'm sorry if it's a little jarring, but I'll just leave you with this. At about 35,000 years ago, it would appear as if most of the old world is populated with anatomically modern. So phenotypically, we look at the phenotype, how their skeletons look like us, right? So how many archaic populations are floating around? We don't know. Maybe a few, We don't know if this is a slow attritional process in which archaic populations are just being genetically swamped with modern DNA, and therefore they become more phenotypically modern over time. That's slightly different than a multi-regionalism model. We can talk about that. But the point being that by about 35,000 years ago, most, or if not all, the skeletal material that we see, there's not much, but when we do see it, by and large, would appear to be modern human. So that gets us to this point where modern humans are all over the globe, right? What happens, how that happens, why that happens, we really don't have a good answer for. I will leave you with, as we looked at the mammoth before, as we looked at Panthera and wolves, similar processes happening with proboscids, similar processes happening with felids. So particularly with Panthera, with lions, similar processes are happening with canids. And because they're elephants, and because they're lions, and because they're wolves, we don't invoke any grand narrative about the later populations of wolves being better or more wolf-like or better at being wolves. We just say there's massive environmental loss or degradation, and as there's ecological collapse and retraction, those populations that live in those areas naturally contract, go extinct, extirpation, you have a local extinction, and then of course whatever population is nearest to that front line, if you will, but able to cling on, will be the first to repopulate. And you can imagine time and time again, it's going to be primarily populations from the equatorial belt and sub-equatorial belt during this time period. And again, there's the whole continent of Africa that for sure would more or less seem to be populated with modern humans, that's constantly acting as a pump, pumping out these populations. If we remember, we did talk about the North African pluvial. So it's also corresponding with the time in which stuff is getting periodically bad, if you want to put it in simple terms, in the Northern Hemisphere. So this is where the majority of archaic populations are. As stuff gets expand, it gets greened. So it's right at the same time in which you would naturally have a population expansion in Africa, kind of allowing that population to migrate out and be right there, if you will, at the gates, ready to recolonize, right? If you want to look at it that way. For me, I think that explains why we see the current diversity in alleles amongst Eurasian and Amerindian populations. So as everyone knows, thanks to 23andMe, most people can go and see how much Neanderthal they are, right? Right. All that means is what percentage of alleles do you have that seem to be derived from Neanderthals, and it's roughly about 1 to 4%, which is a lot. I mean, people should think of that more. That means 1 to 4% of your DNA is being argued to be derived directly from Neanderthals, right? I think that this is what you would see under that model of populations collapsing, anatomically modern humans expanding around the same time. So basically, you're kind of dealing with replacement, but genetic and population swamping, right? So they are kind of absorbing rather than outright replacing the archaic populations that cling on, right?
But the Asians know, right?
Asians have more,
They have
a
more?
lot more.
Really?
Oh yeah, and people from Papua New Guinea and from Australia even more, and that's very problematic for people who. So for me, I don't think archaic humans, I don't think Denisovans and Neanderthals. We don't know much about Denisovans, but we know that they're a sister taxon, basically, of Neanderthals, and we know a lot about Neanderthals. And for me, there's I have zero doubt. And again, I'm in a minority, but an increasingly growing minority in saying what I'll say next, which is I have no doubt that a Neanderthal would be able to sit here right now, no problem with us, have this conversation, understand everything we're saying, and get on with their life. And if they existed as a phenotype, we wouldn't really think anything about it, to be honest with you, in my opinion. You know, when you show most people a reconstruction of a Neanderthal now, I would say most young people, and I mean college students, have no clue that it's supposed to be a Neanderthal, right? They think it's a human, you know? So again, a part of this has to do with how you choose to reconstruct, but I mean, this is using forensic reconstructions, you know, it's, you know, if you assume their hair pattern is similar to ours, then you just, you know, and again, there are people typically, which is something multi-regionalists pointed to, typically Eurasian males, typically. So males more or less from Europe, but from Central and East Asia too, who exhibit sometimes, and that's through processes of hypermasculinity and so forth, but exhibit facial features that are quite archaic, with the exception that they still have a chin. I mean, there are weird things that are different with archaic populations. Early modern humans too didn't have much of a chin. Later Neanderthals did. We don't know why that is. You still see some people without a chin today. We oftentimes see that as a deformity. It's really kind of not. It's just a genetic variation, right? So yeah, so you wouldn't, I can show you some photos later, like some of the new reconstructions, but I mean, they're good, and they're not, in my opinion, they're not done to intentionally make them look more human, right? So that would be my take. But the problem for others, and I would say still a lot of dominant people in the field, although they're getting older and retiring, one of these people who was, they were a good person, very good person, very supportive supervisor, professor, cared a lot for his students, but was knighted for his work. And he was one of the guys who came up with the coasting out of Africa model, actually. He just recently passed away about 4 or 5 months ago. But I would say that he and a large group of people that he was part of and around him, they're out of Cambridge, so really dominant voice, would argue and emphatically argue that there's a fundamental difference. There's a species difference between these archaic humans and us, right? They're different. I mean, that it's more appropriate to use analogies to chimps and chimp behavior in society than to human behavior to understand the archaeological record of these archaic humans, particularly Neanderthals. So that's to get to your point. So I know it's a long-winded explanation, but when people insist on that, and then we see that basically all East Asian populations have a genetic contribution from both Neanderthals and Denisovans, and potentially at a higher rate from Neanderthals. Western Eurasian populations seem to not, except for back migration in some areas like Finland and other places, don't seem to have any genetic contribution from Denisovans, but people from Micronesia, from Papua New Guinea, from Australia have a lot, like 5 to 6%, maybe in some cases 10%. So you start to talk about a lot, right? And then if you follow the traditional narrative, people are kind of saying, well, 10% of your genetic makeup comes from populations that are more similar and akin to great apes than to modern humans. Seems like they're saying the same thing again. Seems like they're saying the same thing they were saying in the 19th and early 20th century. All right, but people want to say the two things and never have to beat in between, right? So kind of people say one thing in this conference room and then another thing in that conference room. If you bring up the problem, you're the jerk. You know, that's what you'll get. Okay, so that gets us to these models of just when and how did people arrive in the Americas, right? So 35,000 years ago, modern human populations, at least phenotypically, across the old world. So in the traditional narrative, that sets the stage for modern humans to get into the Americas. One of the reasons being, literally, modern humans can do whatever they want, right? There's no difference between these people and us who made it to the moon. Therefore, getting into the Americas should be quite easy, right? So that's the way it should be. And I would say that's kind of more the old world European view, right? Because there's all of this, you know, look at how great modern humans are, look at all the technological advancements, all this stuff. They colonized the old world in such a short period of time. They're already boating here and there and this and that. Well, the problem is that runs up against what some people call, and I think maybe John brought this up on one of the hikes, the Clovis Mafia, right? Which is, it runs up against over well over 80 years of established research in the Americas, looking at the early really around 11,500, but let's just say 12,000 years ago, and that's it. They're not there earlier. So we don't care if there's modern humans in Beringia 35,000 years ago. We don't care if modern humans can do whatever they can do. They're not here until 12,000 years ago, right? So that's the traditional model and narrative. And that's where we are, or we were as a state of research, I'd say until about 5 to 10 years ago. But what I'm going to give you now is a picture, again, of all of the confusion, basically. So I'm going to just go through this quickly. So we have, well, quickly for me. So we say when and how did humans arrive? So we have what I'm going to call pre-LGM models on the left-hand side here, and then LGM or post-LGM models. So let's start to focus on the pre-LGM models because they're a little silly, but they're interesting. They're interesting, and if we remember again, and that's why I wanted to start today with elephants, lions, wolves, okay? Well, elephants and wolves and lions are making it back and forth very early. So these models are positing that there were human populations here, and therefore maybe not modern human populations here, much earlier. And so we'll look at those. So the first one is Calico. So Calico, which I hope you can see from this map, is out past Barstow. It's in a big, actually, it's a Calico early man site, which is now closed. This area is actually a series of large alluvial fans. So obviously the area's gone through a series of different processes, which is not uncommon in the Western United States, of kind of, active wetter periods, therefore these alluvial fans. Alluvial fans, what's left over from a water system. And a lot of times they do form in these kind of drier environments where you have wet periods in between because you've got to get a lot of soil erosion and deposition. So alluvial fans can be great because they leave you a lot of material to date, particularly OSL dating, optically stimulated luminescence dating, that we can use to see the last time that bits of quartz were exposed to sunlight. But the problem being, they have high rates of deposition. So they're very, very deep. As a matter of fact, a lot of the lower Paleolithic material from India comes from these alluvial fans. So if people want to excavate them, they need to dig for 5 feet before they find anything, and maybe dig another 20 feet before they find a few more things. And they're not that far necessarily in age from each other, right? So high rates of deposition. In this case, you have these series of alluvial fans. All of that process really ended during the Holocene. And so now we're in a period of deflation, right? So basically you have erosional processes and particularly aeolian processes deflating this landscape and cutting it back, as stuff gets increasingly drier. All the soil's gone, the organics wash away when there is occasional rain and so forth. And that exposes sections of these fans, right? So you do have these exposures, you get terracing and all of this. So, and please excuse me here, I feel like some of the material was found in the late 60s, but it wasn't brought to Louis Leakey's attention until the 70s. And so there's this purported evidence for a whole series of chopper and biface looking lithics all throughout the Calico Man site. And there are a few other sites like this, and they're supposed to be at least 120,000 years old. And Leakey believed this. This is how Leakey went to the grave. So he's the one who went out there. He got this set up as the Calico early man site. He happened at this point to have had a falling out with Mary, with his wife. she was really running stuff, back in Africa. He was out here. He was with his secretary, who was younger. She was in her 40s. And so people were unimpressed with his evidence. Although most of the material is actually at Berkeley today, even to this day. I'm actually I've talked to people about getting in there and looking at it without having people think I'm crazy, because this is the problem. People think you're crazy. But to be honest with you, some of the material looks pretty good. I was going to throw some pictures out here, but I mean, I think if you found it anywhere else, you wouldn't be disputing whether it was artifactual. But in this case, it's an extraordinary claim. The problem with archaeology, which a lot of archaeologists don't like to admit sometimes, is we are a strictly empirical field at our base. So of course, incredible claims, people always go, incredible claims require incredible evidence. Well, we're the field that helped to kind of prove Darwin right. When they first found archaeological material in what was then called the diluvium, which is basically below glacial till, and the initial response from geology, and you have to remember, geologists at this time accepted that they were dinosaurs. So it wasn't that they were like, it's just the Bible and only that. They accepted they were dinosaurs. Dinosaurs were becoming pretty well studied, actually, by the late 1850s and early 1860s. But the fact that they'd found human tools below the quote unquote diluvium, which means flood, they assumed that the glacial till was a series of evidence of floods, was dismissed. And why? Because there was a lack of evidence. You're showing me one site, I think you're misinterpreting the site. I think these aren't tools, or I think you're misinterpreting the geology. Same case here, right? So we go, incredible claims require, a huge, large amount of evidence. Well, okay. So that's in San Diego, the next slide, which did lead to a whole special case cover story in, I believe it was Nature and not Science, not that long ago. I think it was 2017, more work in 2018. So the site was, so it's actually part of this highway project. You can see the highway that it's right next to. And the material was found, I believe, in the 90s, maybe 91 to 92. So when you do these, I've actually been forced to do this work. So there's some people who choose to do it for their life. Some of them do it. Some of them do it for the state and for the park services, which is smart and a good career path. Some of them do it for private firms, which is not a great career path. And a lot of academics do need to do this work to augment their income. My point, reason why I say that is that the people working on sites like this, they're in charge of environmental compliance, basically. So EIRs and so forth, they are very competent field researchers, a lot of times more technically capable than most academic archaeologists, right? So sometimes they get dismissed. They shouldn't be. I mean, everyone knows they're better in the field than academic archaeology, like by a lot, right? I mean, I think I told you guys this before. That's why in Germany, there's two systems and they have to work together. So you have archaeological technicians and you have academic archaeologists. They're two different graduate paths in the same institutions, and they always need to work together, basically, because the technician has the proper field methodology and skills to make sure that scientific methods and protocols are in place while you're excavating to the finest degree possible. So they excavated this material in the 90s, but while they're excavating it, they had already suspected that this was a mastodon butchery site. This wasn't just a dead mastodon. Why does that matter? It's also at least 120,000 years old. So it was quite a sensational claim. They made it into one of the two top scientific journals, period, where the best science comes out in. There were a lot of people remarking on it. It took them, they were very careful, and they took that long. Again, the part of that was a lack of funding. Part of it was caution, right? So it wasn't like, oh, they spent 30 years researching this, but they spent a long time. And when they could get money, they researched it further and further and further because there are people who just wouldn't let it go. Your report goes to the state, that's it, right? So at least these researchers were like, I think we have a 120,000-year-old mastodon butchery site, right? So yeah. No. So butchery is just what we call like when you kill a wild animal, you normally what we call field dressing, basically, in hunting today. But that's what you do. So they sit down, they butcher the mammoth, and so I've looked at the article, of course. I've tried to research as much as I can. I've looked at some follow-up articles, and there's another I think mammoth site, maybe another mastodon site recently, like within the last 2-3 weeks as well, but it's not 120. It's supposed to be more like 25,000 years old, which is still very old compared to 12,000 years ago, right? In both cases, there's a lack of associated archaeological evidence. So in this case, in the site in San Diego, there's anvils and hammerstones that are argued to have been used to break open the mammoth bones to extract marrow, which is a common thing that humans do, particularly during the Paleolithic. So the problem is there aren't really any associated reduced lithic tools. There really isn't anything like that, and it's in a semi lacustrine, like lake-like, pond-like environment. And because it's in that, a lot of people who've critiqued it have said, well, there could have been water movement, the mammoth could have eroded and some of the rocks could have been stacked up this way because of, fluvial or alluvial processes. And, it'd be great if we didn't see that, if we saw the same stuff, but it wasn't in this kind of pond, lake, lacustrine-like stuff. Fine and great. It's just like the people that I read who are making some of these arguments kind of know better than to make this argument. Most mammoth, I'm not going to say mastodon, but most mammoth sites butchery sites are found in these kinds of environments, right? This is where they're found. And the reason is that typically when humans, and even today, like if you look at there's ethnographic videos too, where people hunt elephants. So typically when people go after an elephant, and what it seemed to be the way in the past with a mammoth, because they're so freaking huge, you wait until you find one that's injured. So the only times, I think maybe I've said this before in one of the previous presentations, humans typically go after prime age adults, unlike most other predators. This is not the case with mammoth, right? Because these are huge, right? So we go after sick and older and younger, individuals, right? Which is not common for humans to do. And part of that is that seemingly when you look at the ethnographic literature, people will see an injured elephant, naturally injured. Maybe sometimes they'll injure themselves, but normally naturally injured. And when elephants are injured, they take to water, probably to relieve themselves of their own weight. So when they're sick, or they have a hurt foot, or they have a broken bone, they go and they get into these ponds. Good for them if there aren't humans around, because even typically other large predators won't try to attack a full-grown but injured elephant. They'll kind of let them be. I mean, apparently, occasionally lions will sometimes, but not normally. Humans will. Okay, and because of that, the mammoth, or in the ethnographic case, the it's difficult for them to get out and move. So that gives humans the opportunity to literally jump on them. It takes a long time to kill an elephant and do what they can to kill the thing until they kill it. And then you normally try to dress it there and then drag as much of the material as you can up onto the banks and then process the material there. So while I would say I would like to see a lot more reduced, so you think of traditional arrowhead looking things, right? So rather than hammers and anvils, which a lot of times just look like natural rock, so a lot of times that's what people use, unless they're using it habitually over, normally you get out there and you find whatever big rock you can find when you're there, you use it once and you get on with your life, right? So I would like to see more reduced stone. I'd like to see more of the stones they must have, like the material they must have been using to cut and butcher, precisely the mammoth. But a lot of mammoth sites in Europe don't have much of this other material. A lot of times there isn't lack of evidence. A lot of what you just have are bones that are processed in a particular way. The difference here is there aren't any really good examples of cut marks. So while there are a few, but the problem is, are these bits of abrasions from sand once the bones were already, exposed. So when you see a lot of other butchery sites, so while we don't always get good evidence of the stone tools, you see marks left from them, right? And they're butchery marks, once you learn to see them, and then it can be difficult sometimes to differentiate them from just abrasion marks, but actually not really. And you see them really where you would see butcher's marks today. I mean, they matched up with people, industrially, if they're actually working, you'd see the cuts on the bone with modern knives, butcher's knives and so forth. So it's the same kind of process. And from what I understand, you don't see this. There's one other problem though, which is one of the main people who critiqued it had argued, and a lot of people bought into it, and they barely put it down, and they put it in a comment, so they didn't even write it in a full peer-reviewed article themselves. And what they said was that it was their opinion that even the bone that was broken down wasn't broken in the deep past, that the bones just fractured due to the weight of heavy equipment before they excavated down. So there's heavy equipment that had gone back and forth many times, although this material was deeply buried. And once they came through and excavated it, that he's kind of arguing that they didn't really pay attention during excavating. And so they didn't know how far apart this material was. And that's why it's broken like this. And it looks like it was butchered by people and then left there because you kind of have all the bits of bone to refit. But actually, no, it's because it was broken. I was in the ground. The problem with the researcher making that argument, it's one thing if I said it, okay? This guy is an expert. I won't say his name, but anyone could figure it out. Not that anyone's going to listen to me online, but he's an expert in skeletal taphonomy, which means how bones break down and what it looks like. So he's asking a question he should already know the answer to from looking at, and he doesn't cite the material. He just says, oh, this could have happened. So it seems as if clearly he didn't read the article. He never asked to look at the material himself. He just came up with a hypothesis because this is what he specializes in, right? So the question of could the bone have broken in the ground from something, from a tractor driving over it, when it was still buried? Like, that's an answerable question. The bone breaks and looks very different. Green bone breaks look very different from these other kinds of breaks, right? So it's a very easy. So to just say, oh, and then dismiss it that way, it's like, no, that's a research question. It's a research question that could be answered in 5 minutes, right? So I'll leave you with that. And then the other case, we'll go on to the next one here, which gets even more confusing, is Pedro Ferrada in Brazil, in Nordeste, Brazil, not too far away from where my partner Priscilla's from. And this site actually is a series of sites. So it's in a very large nature reserve. This area is very important, a very large park. And there are a series of caves. And I'll mention this now, not too far away, actually within the same area, but not exactly where the caves occur. You can see this area is huge. That's not the whole, that's the kind of the state, actually. It's not the whole park itself. But there are Capuchin monkeys who do live nearby. Okay, so I'll just highlight that point now. So what you have is a series of caves. I think a lot of them are wind caves. So you have strange rates of deposition. And there's a bunch of what appear to be quartz pebble tools. And those pebble tools are interspersed with charcoal. And that charcoal dates, again, at least 20,000 years, potentially as far back as 60,000 years. So what it would seem like is that you have a kind of semi-typical, almost old world style, cave habitation. You get a bunch of stone tools, you have charcoal, the assumption being the charcoal is there from people making fires. A lot of times, and it was argued a lot about how capable war you know, ancient humans of making fires, because sometimes you see discrete arts. A lot of times you just see charcoal dispersed throughout a level. For a lot of times people thought that meant, well, that's because even early modern humans weren't very good at fire use. It's not really, it's because people who reuse the same, unless you're reusing the same site almost every year, every few months, you don't really typically use the same fire pit. And a lot of times what people do, particularly if it's cold, you take as much of the kind of hot ashes that you can and you spread it throughout the cave. And then you put some grass down, put a little dirt down, you put a little more grass down, and it gives you a nice warm space to sleep on. That's quite a common thing. So this idea of having, you know, bits of charcoal and stone tool interspersed seems quite like, oh, this must be an archaeological site. And so the problem is it's 60,000 years old, right? So again, it's not 120, so it doesn't sound that crazy, like, hey, maybe there are archaic humans who came into North America, and it would have to be at 130,000 years ago, right? So no, but in this case, it's 60 to 30. So it really doesn't seem to work. It doesn't correspond really well with the last glacial maximum, doesn't seem to correspond very well with modern human populations. And the reason why I mentioned Capuchins is that, as I said, there are Capuchin populations nearby. They're not in the same vicinity today of where these sites are. The interesting thing is Capuchins are one of the only other primates that habitually, particularly from this part of Brazil, break down stone. So they break down stone, particularly quartz, and it looks like artifacts. And Capuchin monkeys are much stronger pound for pound than we are. So when you see them, they pick up alluvials. And they take them and they break them. And what's interesting is they knock off flakes and then they reflake a flake, which is something that even chimps who've been known to occasionally make a flake or have a flake fly off when they're using stone as a hammer and then kind of use the flake. Sometimes that has been seen once or twice. They reflake the flake, which makes it really look like a stone tool, because typically that's a difficult process unless you really see some sort of alluvial action, right? You don't normally see that in nature unless you have like a huge rock fall or whatever. And now Capuchins do this to make quartz powder. They eat the quartz powder. People still don't know why entirely. It might be increased levels of salt, particularly if they're from the alluvials. Some of the salt dries, maybe seeps into the quartz, but they break it down. You'll see them. You can watch the videos. You can see it online. Actually, National Geographic did do a part on that. So I'll say that's a National Geographic video you should watch. But sit down and watch it and you'll see them. You'll see them break it, break the flakes apart, and then they sit there and they lick up the dust, right? They discard it. Another thing that Capuchins do is they do use the same alluvials as tools. So they process a lot of nuts with these stones. And as a matter of fact, macaques do a similar thing in Thailand with opening up shellfish to eat, which is a very complex process. In the case of all things considered, in the case of the Capuchins, they will sometimes use other anvils, stone anvils, or they'll use wooden logs, and they will come back to the same place and have a habitual practice of breaking nuts down. And I think I told you guys this. I pointed out where some of the cupules were. So the grinding rocks like we have, and they look like slightly miniature grinding rocks. So whereas most humans, have a diameter maybe 5 inches or 6 inches, these are a little bit smaller. And to be honest with you, if I was out in the field and had never been exposed to a lot of this research, actually from critiquing these archaeological sites and saying, here's why it might not be archaeological, I wouldn't have really known this stuff. I mean, I did study primate behavior a little bit, but I really wouldn't have known it. And if I went out in the field and started surveying out here in northeastern Brazil and came across an exposed section of rock and saw these little cupules, I would have no doubt in my mind, without having known this evidence, that this is an archaeological, this is 100% an archaeological site. No, it's not. It's a Capuchin site, right? So, which is what it is. And so it's possible that in the past, as we know, we saw how drastically different the environment, ecological zones over the course of the glacial interglacial cycles. So to think that 20, 30, or even 100 miles that Capuchins at one point may have lived right up against where these cave complexes are today, 60,000 years ago, sure, why not, right? And the issue of having charcoal dispersed throughout the stratigraphy is that, unfortunately, natural fire regimes, particularly if these are more wind caves rather than karst, meaning that it's through an actual aeolian process, blowing in sediment, so you get that really fine sediment that's blown in, then charcoal is also blown in with that when you have a natural fire regime. So you can get this process of charcoal, you get a little deposition of dirt, the macaques are doing their thing in there, you get all of this stuff. Now, the only thing I would say, because I saw some of this research that was, when it was reappraised and new work was done, is that one of the best lithicists, so a lithicist is someone who specializes in stone tools, a French researcher, has looked at this material, has gone out and excavated it, and he's gone on the record, and I saw, not him, one of his grad students give the presentation, and he's firmly convinced that these are real artifacts. He's looked at the material from the macaques that macaques make. He's looked at this stuff, and he says that no, these are artifacts for sure, right? So it's quite a claim to go out and make, and it's not, a lot of people might go, oh yeah, you'll take that risk because it will make you very famous. It's going to hurt you more than it's going to make you famous, actually, right? So this is our pre-LGM stuff, okay? So then we'll get to our next slide here. We'll get, oh, see, this was the one extra slide here. All right, if you go back for everyone here, just back to the when and how did humans arrive? Yeah, so sorry, for everyone on Zoom, yeah, I have this slide again for everyone here at home. And I just have this little section highlighted that says the LGM and post-LGM. So when we look at the LGM and post-LGM hypotheses, these are more within the realm of what's accepted, okay? Although, and the first one we'll look at is the solution hypothesis. So while it's kind of within the temporal realm of possibilities, so it's kind of within the time frame that most researchers will accept, and this is probably when people made it to the Americas, more or less. This hypothesis is nonetheless crazy. Actually, this is a hypothesis that my first ever scientific article that was peer reviewed and all that published was a critique of this hypothesis. So I know the solution hypothesis pretty well. And unfortunately for all the other students and grad students who want to try to write on this themselves, they have to cite me and my colleague from now on, since we're in the long line of arguments over this hypothesis. And the other one is just, basically Clovis first argument, more or less, and then the coastal migration argument. So we'll go, well, you can go ahead there to the next. Okay, so we'll leave it at bifaces. So if you remember from my rant last time where I said, sometimes bifaces just happen, sometimes microliths just happen. And the issue with the North American record, and you'll see even the things that are argued to be pre-Clovis, is it's bifaces. I mean, this is giving you everything from the end of the Pleistocene, so we're at 12,000 years before present, up to 8,000, and this just continues all the way through. That's why when John and Brian and I were out on a hike and we found a little biface, smaller, who knows? It could be almost all the way up to present. So in North America and in Central America too, bifaces are just a dominant characteristic of the archaeological record. Okay, bifaces are not a dominant characteristic of the Upper Paleolithic. Quite the contrary. So the Upper Paleolithic is the kind of archaeological evidence and spread of material culture that's associated with anatomically modern humans in the old world, right? So as a matter of fact, bifaces, although these are pretty bifaces, I'm not trying to say that they're all the same, but bifaces in particularly Central and Eastern Europe, and then therefore it causes confusion as we get out into Central Asia, bifaces are associated with Neanderthals, with the last kind of material cultural trajectory of Neanderthals in that area. So if you find bifaces and your site is 50 to 45,000 years ago, and you're in Poland, a lot of times the assumption is this may just be a Neanderthal site. But if you find blades, if you remember blades and bladelets, people go, this is a modern human site. So why do I say, what I say before times bifaces just happen? Why am I highlighting this? Well, it creates a problem, right? The problem is humans come into North America, for sure around 12,000 years ago, we get bifaces everywhere. We have Clovis after 12,000 years ago. It has a wide distribution across the continental United States. It has a distribution into Central America as well. And right around 10,000, maybe even 11,000 years ago, you get what are called fish points in northern South America. They look like a trajectory, a cultural trajectory out of the Clovis, right? They look similar to this, right? The problem is there's really nothing in the old world that corresponds to this. If you're going to be strict, that's why I say, remember, science bifaces just happen, right? So whatever reason, the population, regardless of who it is, when they get into the Americas, they like to make bifaces. And so even the little tools they make that aren't big spear points, they're not dart points, they're also bifacial tools. You make a bifacial knife, you make a bifacial scraper. So it's flakes and bifaces. And really the only time you see flakes and bifaces in the old world during the late Pleistocene is it's normally, not always, but normally associated with archaic human populations. It may seem, just for a caveat here, it may seem that some of the very, right at that transition between the Upper Paleolithic and the Middle Paleolithic. So right when modern humans are, let's say, in Central Europe and Eastern Europe, maybe into the Caucasus and so forth, there are really nicely made. This is where stuff gets very qualitative, right, rather than quantitative. Very nicely made bifaces. Well, then they are. They're beautiful, and they look more like the stuff we see in North America, but they're very pretty. They're very uniform. Those may be associated with the earliest modern human populations. That then begs the question of how influenced were they by the Neanderthals, you know, and so forth, right? But when you get what's considered full-blown Upper Paleolithic sites, it's blades and it's bladelets. The bifaces go away. You don't see them in, if you remember, in Western Beringia, so meaning Eastern Siberia. You don't see them. You don't see them at the time in which we would think these populations are going in to the Americas. I don't show you a slide here. I'll just jump ahead and tell you there is something called the Diocti, which is a biface technology. It does occur in Siberia. Problem being, it occurs roughly at the same time, really after the Clovis, and it doesn't extend into Western Beringia, right? So it doesn't extend into Eastern Siberia, and it's not seen in Alaska at all, right? So again, sometimes people just make bifaces, right? So some of the Diocti stuff does look similar to North American bifaces, but it's later and very far away, right? So that's a little bit like saying, you know, where's the Lamborghini factory, right? You know, I see a lot of Lamborghinis in LA and I see a lot of Lamborghinis in New York around the same time, but where are they coming from? Right? You never think Italy, right? And sometimes, and in this case, unlike bifaces, people just don't make Lamborghinis, right? But people can just make bifaces. You have to remember, this is always an option. And for anyone who was here before, who remembers when I went through the mode system, bifaces, bifacial technology emerges in the lower Paleolithic, right? So the idea of working a bit of a nodule of stone on two different faces around the perimeter of the stone goes back over 1 million years, right? So again, it's a pretty effective way of working on stone, right? You know, and there could be other economic reasons why you would go back to that. And I would say that it's always within the technological capacity of humans to do this, right? It's always going to be there. So what does Clovis look like? So a lot of this gets down to, and these arguments get down to, how do we deal with bifaces? And in North America, we have an interesting, I think, tradition in regards to the way in which we examine the archaeological record, particularly the Pleistocene. So the late Pleistocene, early Holocene. And we have a really kind of fine, detailed look. And a lot of times, and I think sometimes to our deficit, a lot of it's within what we call a cultural diffusionist and cultural tradition model. So we look at things as having an epicenter in distribution. And then we look at later periods of the archaeological record as descending from those previously existing technological and social traditions, right? So it's a very diffusionistic model, which in reality is a very old way of interpreting the archaeological record. It's not necessarily wrong, it's just a very old way. Here are Clovis bifaces. They're beautiful, they're nice. A lot of them seem to not even be functional. Now we're not seeing them on the side, but they are intentionally made with a particular kind of flaking method at the end to make them as thin as possible. And then you make this crescent base. I hope you guys can see that the base is in a crescent shape. And not always are Clovis bifaces fluted. In this case, they aren't, which I think this is from a cache. So you also find these caches where they make a bunch of these things and they bury them. So they may be not entirely complete. But what people do typically as representative, and you can see it a little bit, maybe on the bottom example here, is that then you, what's called fluting. You flute the base. So after they get through all this work, they'll make a large pressure flake removal at the base, and then that removes, it's oftentimes on both sides, a large flake up the middle. And it seems to be to increase hafting capacity, at least at one point, right? At least at one point when these things maybe were made to be more functional. It seems like a lot of them may have been made for ceremonial purposes, although for sure, some of them were used. Like the original Clovis site, one of these bifaces was found embedded in the back of a bison, I believe, right? So, you know, they were used, but a lot of them weren't. So what is that in contrast to? And here's your, sorry, next slide here. This is your, see, this is where I put in 2 more slides. So everyone here and everyone there, sorry, I sent you the next set, but I should have told you before we came here. So for everyone, I'll just address everyone online and I'll turn this around here for people to see real quickly. It's my fault here. Here's an example. This is actually from material from the Channel Island site, which we'll get into in a second. This is one of their pictures. So this is in contrast to what's called a stemmed tradition. And the slide that we showed, the biface chronology of North America, all that is a stemmed tradition. So for the most part, particularly in the Western United States, the stemmed tradition takes over and becomes dominant. It's bifaces. The difference is sometimes these bifaces aren't as thin, but then the base, rather than being crescent, has this stem. If you guys see the biface in the hand, and then a lot of times those are associated, particularly early on, with these little crescents, right? In both cases, these are bifaces. They're both reduced bifacially, right? And what goes along with Clovis aren't bifaces, but they're not crescents, but they're bifacial scrapers and so forth. So we see this difference. And because, again, it's North America, because it's North American archaeologists, and we have a difficult time dealing with these kinds of differences without creating some sort of separate cultural trajectories, right? Because they look different, we can't accept that somehow people in the Western United States who did make Clovis bifaces just decided to make stem points. That can't be. These must be 2 different discrete traditions, or so the argument goes, right? And then we have these things which are becoming increasingly, and this is the slide we have here, increasingly difficult to argue against which are pre-Clovis sites. And the point of showing these pre-Clovis sites are just to highlight again that for the most part, it's bifacial, right? So even when we're not dealing with Clovis or stem point, so some of these sites that are a little earlier than both traditions, they're bifaces, you know, and it's a diversified form of bifaces. What goes along with these pre-Clovis materials sometimes are more just flakes and just kind of semi-prepared, like kind of like or discoidal flakes. I don't have to get into what that means, but you see that. I mean, you see that too on the stem point and in the, you know, so it's not truly a bifacial reduction system, but it's a flake system. And in both cases, it's the flake and biface. And so some of these sites like Buttermilk Creek, where they make some, sorry, it's not even on this map, but it's in Texas, where they make some really nice looking bifaces and so forth. So the material looks good. To me, some of the other flakes and everything look a lot more like almost a late middle Paleolithic rather than an early upper Paleolithic. And regardless, we're way past, I mean, we're way into the upper Paleolithic and the rest of the old world, right? So again, sometimes people just use these traditions. Okay, so this kind of, again, confusion of evidence. We have Clovis, we have some stem points. Later on, most things seem to go away from a Clovis-like trajectory and get more stem point-like, actually across all of the Americas. Despite the Clovis Mafia, there's increasing evidence for a pre-Clovis occurrence in the Americas. And of all things, the worst for everyone being Monteverde down in Chile, which might be 18,000 years old. And even though members of the Clovis Mafia went down there and looked at the site and read the data and looked at the radiocarbon dates and were like, actually, this is a real site, right? So we have some problems. So that gets to our next page. So then that gets into our next tab here. Okay, so that gets into these three different models, just to give you the background. And again, in my opinion, it comes from a confusion of evidence, right? The fact that the evidence is confusing, it's few and far between, and we want to figure out how stuff works. So one model is still effectively the Clovis first argument, which is these Clovis people carrying Clovis bifaces. They make their way through effectively Thuringia. At some point, they start making more bifaces or larger bifaces. They make their way through the ice-free corridor. They get kind of almost right into the center of the continental United States. And that's why you see this very rapid expansion of this population all over. And therefore, Clovis seems to just appear across the Americas. There you go. And yeah, maybe we have to modify it so crazy. And then you have the coasting model. Again, not so crazy, in my opinion. Sure, why not? People could have been coasting in. I don't see why people couldn't have been doing both. But in both cases, it comes down to people, in my opinion, insisting that stem points and crescents and kind of Clovis crescent bifaces and scrapers have to be two discrete traditions, because in their interpretation, they're just so different. In my interpretation, they're not. they're not that different from each other. I mean, they're they for sure probably had functional differences. And the reality is, just like today, probably the Western United States was, I mean, the West Coast had a discrete set of ecological conditions that people needed to adapt to, right? Which is probably why you see more of these probably slightly smaller projectile points and crescents. And the crescents seem to be used for, used to think they were being used to harvest maybe grasses. They actually appear to be like a ground drill in some cases. So maybe used to help drill out or extract like below ground tubers and stuff, which we see a lot in the Western United States up until recently with camas and other things, right? Soper, camas, other stuff. And then the other model, which again gets down to this issue of where the bifaces come from. That's all this model is. Where the bifaces come from is the solution hypothesis. In my opinion, it's totally insane. So as I said before, as we approach the LGM the glacial maximum, the glacial, last glacial maximum, the ice sheet in North Atlantic expands, dramatically. So it comes down, particularly during the winter, and you could technically, who knows how stable it was the whole way, walk your way. And if you have simple canoe technology, the assumption is it's using both, or kayak technology, that you could walk your way, clubbing seals all the way from the Bay of Biscay to the Chesapeake Bay. Okay, so that's the argument. This is what people did. And the reason for that argument, next page if we can, is this strange occurrence. So dismiss everything I said a second ago, which is the Upper Paleolithic is all blades. This is true. Don't get me wrong. The Upper Paleolithic is all blades. It is. For some reason, the Solutrean, which only occurs in northern Spain, perhaps there's some occurrence of it in southern Spain, and then in southern France, makes bifaces. So the previous tradition before the Solutrean is Gravettian. It's heavily bifacial. Even the things that, there's a Font Robert point, just for anyone who would know this is just not very necessary information for all of you. A Font Robert point can be worked bifacially, but the point is it's still off a blade. So they make a big blade, and then they normally unifacially work one surface, okay? But that's early in the Gravettian, that goes away. So the Gravettian is those bladelets. It's actually a very, like, if you remember, sometimes bladelets occur. So they're little blade tools, multi-component tools. So does it mean that they didn't have spear points? Yeah, they did, but they'd probably use a series of little bladelets lined into a bit of bone, which is what they seem to do, or into a fire-hardened piece of wood, right? And then right at the point where you would think that people are the most desperate to conserve their resources, right? Every resource they have, because we're approaching the LGM. So right when you approach the LGM and get right to the other side, for some reason, and this is actually where the archaeological tradition in Europe splits apart. So in Eastern Europe and the Mediterranean, you get the Epigravettian. You just get a continuation of doing things that way. In Western Europe, you get the Solutrean. And these are Solutrean bifaces. Solutrean bifaces don't look perfectly like Clovis bifaces, but there are some similarities. And there are some similarities in the way in which they're reduced, one of them being how darn thin they are. So a lot of people will argue that the only difference between the Solutrean point and the Clovis point are just two more reduction steps. The difference is, if you want to make a Clovis biface, you take your Solutrean point and you just turn the base into a crescent and you flute it, which can be 3 more minutes of work, if you know what you're doing, right? So that's the argument. And it's literally that simple. And it literally is that. They look similar enough. We know there aren't any bifaces in Eastern Europe where there should be. Where are there bifaces in the late Pleistocene in the Old World? They're in Western Europe. Again, the problem being, one, really no evidence other than some slight convergence in technological similarity. And 3, even our climatological models don't seem to fit the dates. So when this ice sheet is stable, it's a little early. So you run into the same kind of problem. You run into the same problem always, right? Which is, in order for the Solutreans to get into North America, they need to leave no archaeological evidence for like 2,000 or 3,000 years, right? And then boom, all of a sudden they show stuff again. There's many other problems. They rely on genetic evidence that isn't very good. I analyze that. Okay, so, we have our next thing here. This is where we start to look at that. Sorry, our next slide. So again, this is just, reiterating some of our models, some of our, migration routes and ecological conditions. And I'm just going to skip ahead because I've been wasting a lot of time here today. Go to the next one. And this is just to reiterate what stuff looks like in general, okay? So for all you guys here at home, as I said, the problem is, what do we see in Beringia? What do we see in Beringia before we see the pre-Clovis stuff, before we see the Clovis and stem point material? is these are all little cores. So it's very different. So those are all little bladelet cores. That's what's left over from knocking off your blade that's going to be used. And I hope you guys can see that, right? And they are small. I mean, they're pretty small. So this archaeological complex of these microlithic, tool complex that defines the Beringian kind of late Pleistocene archaeological material. There's in eastern Beringia, so in Alaska, there's the Nenana complex, which is this kind of biface technology. Now there is the Chindaden, and they do make bifaces, but they make little teeny, they really actually very small little bifaces. Some of them have a slightly crescent base sometimes, but they're very small. But again, for me, sometimes people make bifaces. And the interesting thing is, sometimes when you see microliths and bifaces, sometimes they go together rapid, like in succession, right? Where it seems to be functional for a long period to make microliths, and now it's functional to make bifaces, but it seems to be a very large technological leap. And I would just say it's not. Like I think we discount how technologically capable these stone tool makers are, right? And the fact that people are spending their lives doing this from a young age. So even though we see the record dominated, for example, with these little microliths, or maybe we see the record dominated with bifaces, I would think that when you really break stuff down, all of it is ratios. So you do see that people actually do have a slight capacity, like let's say they have a capacity for sure, although it's low demonstration. You will see little like elongated flakes. So it's like clear people know how to make elongated flakes. Like if you know how to make an elongated flake, it's effectively a blade, and if you want to keep working on that, you'll figure out how to make a blade within your lifetime, particularly you and your friends working on it, right? I mean, it's just, and you have to think, this is what people did. Like think about how people nerd out over, I nerd out over archaeology. People nerd out over fixing their cars and souping up there, right? This is the technology, right? This is what people would have done. Okay, and so again, just to reiterate some of these things, we can get through it fairly quickly. Actually, we'll just skip ahead to, because this one's just showing the progression of the ice sheet. Just skip ahead to the next. Yeah, so again, all of this also comes down to, if we dismiss the Solutrean hypothesis, like why are people so emphatic that it has to be ice-free corridor, it has to be the coasting out, coastal migration route? For me, I think they can be both. Here's a model of how this kind of stuff might look. You have Folsom, you have Clovis. Folsom's kind of like Folsom normally is considered to come kind of after Clovis, but it's kind of somewhere in between, like a stemmed point and a Clovis. It's what seems to continue. We can go on to the next slide, actually, because I don't want to take everyone's too much time here. So the next slide's just what I'm trying to show is like, what are these arguments? There's a lot of work going into this ice-free corridor to try to see, what was going on. I pulled up one of the latest studies by Clark et al. And, though some people say the ice-free corridor could have opened up at 16 to 15,000 years ago, thus explaining this early pre-Clovis material still under traditional, land migration without having to use a coastal route. You don't need to assume two different technological systems and all of this stuff. The most recent study is arguing currently that corridor only opens up at 13.5. If it only opens up at 13.5, then you do have a problem with like, how did this pre-Clovis material get there? So people who want to argue for a coastal migration and a real difference between the stem point and Clovis tradition would say, no, people were coasting in. You have this diversity of bifaces. The people who really hang on are this stem point tradition, and then Clovis come in a little later, and they're two different discrete traditions. We can skip ahead one more just to give you this breakdown. Yeah.
Probably be the case, but if there is a coastal migration, are there any evidences at all of rules that we can use to navigate? They're all.
Now, what you try to look for is clear signs of marine exploitation. So, you know, the guys who are arguing for the solution hypothesis, there is some evidence for marine exploitation in Cantabria, northern Spain. And I think that's good. Like, you need to show that people are exploiting marine resources for a significant period of time before you're going to say that those people are investing heavily in like a kayak or canoe technology. Like, these are expensive. Like, we just know that ethnographically speaking, you know, like, while we can watch some, you know, YouTube videos of some guy sitting there, you know, going out into the bush and making a dugout canoe for themselves, you got to think even in that video that seems like here's one rugged person who can do it on their own. It's like they had to learn how to do that from someone, right? They had to know where the proper place was to go out into the bush and find this stuff. They clearly didn't make their axe that they used, or very rarely. Occasionally you might see someone, you know, actually bringing out their own stone tools. Particularly you see someone going out there with an axe and doing this. And in that case, there's a huge supply chain distribution that involves thousands of people across the globe for that person to have that one axe and then to make that dugout canoe. And that's what we mean as archaeologists about technological investment, right? So you got to think, like, in the past, it would take a lot of people, a lot of different people, a lot of different bits of knowledge retention just to make one kayak, right? It's the same thing like stuff we take for granted, like fish nets, fish nets, and then terrestrial nets for netting animals on the land too. Incredibly expensive. They're incredibly expensive for lower income, you know, populations along rivers and waterways to this day, right? To this day, like net repair is expensive. So, you know, think about how much people need, even if they're ordering it from something like Amazon, right? You know, takes a lot of time, a lot of collective money to get that in, and then the repair and normally that's a high degree of what we would call resource intensification. So you need to see, so while we're not going to see, you know, really good evidence of seafaring technology in regards to how people orient themselves, again, the assumption is always still going to be that they're basically hugging the coast anyway, right? So like, they don't really need complex navigation equipment. They need comprehensive geographic knowledge, right? Because they're always going to navigate within the site of the landscape, right? But what you would hope to see is faunal exploitation, at least, you know.
So just skipping ahead,
Yeah.
About 2,000 years ago,
Yeah.
Correct me if I'm wrong,
Yeah.
around the Channel Islands, there's evidence that lingers now that they mastered the canoe, right?
That who did? What was this?
Around the Channel Islands, the carve
Oh,
out.
yeah, around 2,000 years ago.
Yeah,
The dugouts there.
maybe it was 3,000.
Yeah, I think it's a little. Yeah, I think you're right on 3,000 or something like that.
So
right,
when
with
we
like
get
Chumash and
into
stuff.
the more modern times in California, we'll get to that.
Yeah.
So,
You know, and again,
preview.
yeah, and so that stuff's interesting. And again, like, when you see the associated archaeological material, there's a significant intensification of marine resources that goes hand in hand with the further exploitation of the Channel Islands, right? So when you look at the mainland archaeological sequence, you have these, I mean, you could see a very intensive use of fish and shellfish and so forth.
So just one more footnote. There was a fierce debate about whether this technology actually could have come from Polynesia.
Mm.
And there's a scholar in Hawaii,
Yeah.
maybe you know about it, who made that argument that, the canoes, the dugout canoes and they were hard to make. It took 500 man hours to make one of these dugout canoes, but that technology came from Polynesia. And then there's a whole bunch of stuff about the possibilities of the Polynesians affecting California development of Indians. Why why do we have chickens that apparently came from Polynesia
Yeah, I
and
mean, it's
Asia?
bad. It's bad. It's bad. I mean,
I mean,
the evidence is bad actually for chickens being here before.
I know, but and this has been discredited, right? That I mean, I think the
Well, no, I
debate-
mean, there's some chicken remains that are like right at the point of contact in
so
some
you know,
weird
we've
places.
been talking about
you know?
wolves
Yeah.
and dogs and cats and chicken. I mean, it's fascinating. I just got to say, what you guys know and what you can gather from evidence, it's just all tons of possibilities. Excuse me
No,
for
no, no, no.
interrupting.
So the only thing I wanted to highlight was that so these models looking at the ice-free corridor. So while I think that we need to rely on good evidence or sorry, there's a lack of evidence. There's always a lack of evidence. But we need to rely on good studies and modeling. And in the case of this most recent study, they are looking at field evidence. They are actually going out and taking, soil cores and so forth to try to assess, when this ice-free corridor was open between our two ice sheets in North America at the time. If you look at our kind of temperature cycle here, that's all this is really measuring. So there's no more complex information here. I stole it from Wikipedia, but it's a well-known climate model. So you can see the LGM, which is on the left. They say 20,000 years ago. It's really 22. Again, I told you guys, archaeologists and paleoenvironmentalists like to trick each other and everyone else with improperly calibrating. So even though this says before present, that line should really be 22. This is more like not before present. This is C14 years, but they still put BP. It's actually it's something people call each other out for, just to let you know. BP should almost always mean calibrated, but people forget that, right? So you'll see C14 years, basically, 14C years. So yeah, it says KYA BP, not calibrated. Doesn't matter that much. Well, it does a little because we got to push every date back a little, right? A little bit. So what we're seeing is you can see how during the LGM, we have this very cold period. We had the Heinrich 1 event, which is very important. I don't need to explain what Heinrich events are. They're actually North Atlantic events, but they do seem to capture some sort of process globally that's occurring, right? So it tells us something about the extent of this glacial front, basically, over the North Atlantic, and that does have knock-on effect with the rest of the world. So you can see the Heinrich event is this other really cold event following the LGM, but really starting around 15,000 years ago, you have this sudden, 16 to 14,000 years ago, you have this sudden warming trend. So you have this total reversal. So you go from MIS3 being a failed interglacial, as we talked about, and then you go into an actual glacial. So say 67,000 years ago, it just keeps getting colder and colder. There's some good parts in between, but the overall trend is like this. And all of a sudden it goes up, right? So it's down, 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 down. It's really bad 22,000 years ago. It doesn't get that much better afterwards. It gets slightly worse. And then it turns to temperatures like today, right? At around 15, 16,000 years ago. Well, that's followed with the younger Dryas. So the older Dryas happens a little bit before on this other side here, basically with Heinrich 1. And paleoclimatologists. So when paleoclimatologists recognize this event, it corresponded with intensive work with archaeologists who could see, for example, really bad consequences in the Levant. We're starting to get into not farming yet, but intensification, epipaleolithic. So if you want to, like, for real, there's a narrative here, and it's not an untrue one, that the discovery of the younger Dryas in the 1970s and early 80s is what led to the scientific community becoming very concerned about climate change, about future climate change, when you can actually firmly detect a slight oscillation So not too much of a temperature change, in this case going down, not going up, but then correspond that globally with major changes in what we would assume to be human population densities, arguments for population collapses and so forth. Why does it matter in this case? It matters in this case because, and again, this is an unfair criticism perhaps of this recent article saying that the ice-free corridor could have only been open after 13.5 thousand years ago. My point would be that I would assume that the corridor was still open, right, after the Oligdryas, could have been open for thousands of years, and then closed again. And how are you going to detect that it was open and closed over that short period of time, even if you're coring, even if you're doing soil coring? You're probably not going to see it that well, because any superficial sediment, and again, it needs to be open for a couple of thousand years. Because I think there has to be soil formation, and there has to be enough grass or flora growing in there for the fauna to make their way through. But even still, it would be so superficial that it would be just scraped away by the ice sheet contracting again, right? And then the flooding events afterwards, right? So there's another thing that I bring up here we can talk about afterwards. So yeah, so my point would be, I would still say that even though people are saying, hey, here's evidence that the ice-free corridor doesn't work, right? There's no way that, most recent work this year, there's no way that people could make their way through. I know that I'm arguing against what they were arguing against, and they're saying they've definitively kind of closed the book on the subject, but I just kind of think, no, like it's again another issue where, again, there's going to be a lack of, my model, my hypothesis, my explanation accounts for a lack of evidence, right? Because the evidence is going to be scoured away. Okay, so what do we know? Okay, so what we do know with the Western United States is that, and again, this evidence is normally used to support a coastal migration hypothesis. Unsurprisingly, it's the same group of researchers, or typically the same group of researchers, or the same overlapping groups of researchers from the same overlapping universities doing this work. Is we have Paisley Caves, which is just kind of north of Lakeview, and Lakeview is on the really very close to the Oregon, Nevada, California border. So we're looking at kind of central Oregon. And today, this environment, those lakes actually near them, like Summer Lake and stuff, not everyone is alkaline, but most of them are alkaline lakes. So it's quite, inhospitable today. We talked about this before. You do have this western pluvial at the late Pleistocene, so the environment would have looked very different, probably would have had a much larger population density. Paisley Caves is an old site. It is one of these potentially pre-Clovis sites. It probably is a pre-Clovis site. So I would say that there's good evidence that people are at this site at least 13, probably 14,000 years ago, right? So if they came here, it would have to have been during this hypothetical earlier opening of the ice-free corridor, or they coasted in. To me, I don't care. I don't see why it couldn't be both, right? Okay, so we have Paisley Caves. Then we get to the next one, the next slide. This is just a jump around. So we got Paisley Caves, which is inland and north of us, okay? So inland north of us. And you have to imagine that for supporting human populations, right? So for supporting human populations and at high density, even though it's colder, Paisley Caves is more hospitable, right? So north of us, east of us, right? Where we are now in the Bay Area. And the next bit of evidence comes from the Santa Rosa Islands. This for sure is used to try to argue for a coastal migration route. Those are the little, that's the stem point and crescent come from these sites that I turned around and showed you guys here. You guys saw it online. And again, these sites are at least 13,000 years old, maybe 13,500. And in both cases well, Paisley Caves was found more recently, but I think there's a couple of things going on, and I'll get into why that's important in a second here too, in relation to the Bay Area and potential archaeology here. Some of these sites were already known, and as I said before, there's been new ultrafiltration methods for radiocarbon analysis. And with the new AMS and ultrafiltration method, a lot of older dates get pushed further back. And sometimes I think that really what we should do as a field kind of globally is to acknowledge the fact that a lot of dates, not in every case, but in most cases, we have to push our chronology back a little bit. So it's like we have to push our arguments back in time, but we kind of don't do that. People go out still and pick sites. Kind of, in my opinion, maybe not in this case, but I know in other cases in Europe where people go back out to older sites because they know they can push dates back. The reason why they know they can push dates back isn't really because they're finding new evidence. They're new bits of charcoal and bone to be dated, or sometimes they're even pulling out old charcoal and bone from museum collections and redating them with the knowledge that the date's probably going to get older, right? So I know that some of the earlier dates, I think from the 80s and 90s on Santa Rosa Island, were already like 11,000 years old. So it's like, and maybe some of those wore AMS, I don't think they wore, but if they weren't, then anyone worth their salt would know we can probably push these 11,000 year old dates back with $500. We just need to send it to Beta or the Oxford lab, and we'll have an old site, right? Does that make sense there? So, okay.
Can I,
Yeah, of course.
Before you go on, so these are the
these are all the series of sites. And
yeah, but these islands, so there's 4 of them.
Yeah.
But back in the day, the water level was 300 feet lower. And those were all part of one island. I think it was called Santa Rosita or something like that. And there may be other sites that 300 feet down that someday,
or at least 120, like,
whatever.
Yeah, sure. And I mean, that could be done. Like we talked about this before, people do dredge archaeological material out of the English Channel, for example. That's not an uncommon thing. And there's a fair amount of archaeological work that's been done in the English Channel. You know, and I think people are looking into this on the Channel Islands, for example. But this is just to get to our final conclusion here. We're actually there at the home stretch, which is just to say that we have 2 very old sites, one north of us, one south of us, by quite a bit. Okay, that's quite a bit north, quite a bit south. But if we get to our next slide, what it means is that people around 14 to 15,000 years ago are exploiting the West Coast, whether they're getting there by boat or whether they made the crossing across, you know, the Sierra Nevadas, even across the Rockies, which could have been possible. There could have been ways to do it. There are people here that long ago. And the San Francisco Bay Area, as I was describing to you guys before, and I hope you can see, sometimes people like to say that you just have one large river system. Like we do have effectively the Sacramento River running through it, but the San Francisco Bay was actually a large delta complex, which I hope we can see from this map, far more extensive than our current delta. And in these kind of wetland environments, these are some of the best places for human populations. So you would have mosaic oak grasslands, perhaps some pinyon, different kinds of edible, pinyon, so kind of edible pine nuts. So more pine than you have today. But if we climb up towards Castle Rock, for example, where you get the pine and you get some of the oak, so maybe slightly more of that in some of the lower elevation areas, grassland, oak, and then these extensive delta systems. This is where you naturally, particularly in temperate environments, get some of the highest naturally occurring human population densities, right? So this is like paradise, right? So even better than the bay today in some respects, which had potentially some of the largest, highest population density in North America, but at the time when the Spanish came to colonize and start the missions, right? So it's noted in the kind of ethno-historic record, by the Padres, by Spanish, and then even by early Anglo visitors about how large the population density was. We know that there's extensive language diversity in California and the Pacific Northwest in general, compared to a lot of the rest of the world. Typically, when you have a high level of linguistic diversity, it suggests normally a very large demography, which again, in and of itself suggests a very high carrying capacity, natural carrying capacity. So what is the San Francisco Bay described as, or this whole area from the Central Valley through the Bay up to Point Reyes during this time? It's actually referred to as a California Serengeti, is what it's referred to. And the reason for that are the huge number of faunal species supported, particularly a large spectrum of predators. Now, some of these predators do start to die off as populations as we increasingly go through the Pleistocene, but even at 15,000 years ago, you have a very bioproductively rich environment, basically, right? So in my estimation, we know people are here. And just like in more recent history, where is the population going to be heavily concentrated, right? In the past, right? And this deep past, it's going to be, even though it actually potentially for the same environmental reasons, but more, greatly amplified, which we wouldn't assume during the Pleistocene, right? Late Pleistocene, is that population density is going to be in the Bay Area. It's not going to be at Paisley Caves. It's probably not going to be down at the Channel Islands, although again, you have a capacity for, huge amount of marine exploitation for sure, which is always good for people, but here in the Bay Area. So, and not just here in the Bay Area, but I'll show you our little slide. So as you can see this is going from the end of the LGM into effectively the pattern today. So not just in the Bay Area, and this is important to look at. Yeah, there we go. So you go to that screen.
All right.
So, sorry, I thought everyone saw that here too. I was looking at the screen online. So this is showing the geographic change over, yeah, there you go, from the end of the last glacial maximum to present. Okay, so why does that matter? Well, the first thing you would say is, which would typically be there's a lack of evidence for the same reason. No, I'm not going to say that. It's not the case. Of course, where a lot of the population density would have been concentrated is now underwater. And it's not just underwater, it's under large sequences of what's called bay mud. So it's only the, it's only ever touched by our geoengineers when they're making skyscrapers in downtown San Francisco. And yes, sometimes they do find there was an 8,000-year-old burial in some of this kind of bay mud sediment. But why does it matter? Well, what it matters is, and I hope you see, this is the North Diablo Range. There is Mount Diablo. That's effectively conquered and yeah. So this is all of us here. We're here in Walnut Creek. And as I said before, with the American Discovery Trail, right? That, while the San Ramon Valley may have been usable when it was a little, when the water system were kind of pushing more towards the bay, these corridors, that are part of the American Discovery Bay today, that are right outside our window, that, you know, John's house here with the end of Indian Creek, this is part of these corridors. And the fact is that these areas, fortunately, are largely untouched and unaltered from this time, right? So even though we have a massive difference in regards to the sea level, there haven't been these enormous environmental and ecological shifts, right? So there's actually been a lot of surprisingly ecological diversity, which means there's been a fair amount of somewhat more uniform sediment formation. And the only thing we've gone into is a slight period, probably of a deflationary process along these corridors. Down in the valleys, we've had deeper deposition, which is why it might be a little more difficult to get to this stuff. But if we're going to actually go and start an archaeological survey right out here through the North Diablo Range, what we need to do, and if you just look at the USGS maps, and they're there, I was looking at them today, and the stratigraphic formation, they were little clusters that have already been mapped of Pleistocene and late Pleistocene sediment throughout these valley corridors. That would be a high probability area. And you go out there and you start excavating, you start testing, and again, I guarantee you, you will find a very old site. And to that end, one of them, which we already know is an old site, the next slide, is Vasco Caves, which we talked about. Now, I would not suggest going out to Vasco Caves and digging around there, because it is, as I mentioned before, a sacred site for our, you know, Native American indigenous community members, right? And any of this kind of excavating, whether it's me or any other researcher who wants to do this, needs to do this work in consultation and cooperation with our, you know, with our fellow community members, with other, you know, with the tribalists and different tribal representatives, for sure. But Vasco Caves is, yes.
So it's a regional preserve, but they do offer guided tours.
Yeah.
You have to call months in advance. I've been on the site. I know how to, I think, do it. They don't start doing it until the fall because of fire season, but God, you know, who knows whether they'll do it this fall. But that may be in our future.
Yeah, that would be great. And so Vasco Caves is a series of caves that stick out, you know, off of Vasco Road. This is kind of a meeting point of a lot of these traditional paths, right? So basically, if we keep making our way down our pedestrian route on the American Discovery Trail, you can branch off and get down towards the old, you know, Vasco Pass. And obviously people now use, you know, people now go up over 580, right? So over the Altamont Pass. But, you know, anywhere, particularly any of these street signs where you say it says pass, it says pass. Ignacio was a pass. These are actually very old routes. You know, we don't like to think of this area as being old. Like a lot of these things are old pedestrian paths. And then they were used by the early Spanish, and then of course by the, you know, by the old cowboys, by the old Mexican cowboys, the early Anglo cowboys, and so forth. And so, you know, that whole Joaquin Marietta Trail and all of this, right? These are all old pathways, right? And so it's down these corridors in which, you know, these populations would have been moving during the Pleistocene as well. And like, I guarantee you'll find a site if you look hard enough. And I think it will be old. And I think we have a potential for finding large sites, and we have a potential for finding a lot of sites if we choose to really look. Again, Vasco Caves itself was just kind of low-hanging fruit. That's a traditional way of doing archaeological research. You go, there's a pass, there's a cave near it, let's dig in the cave. There's probably archaeology. Sure enough, there was. I tried to find one of the earlier reports that I had dug up. I think it was one of the last ones in the 80s. But I know some of the radiocarbon dates in that article were at least like 8,900, I think, on the regional site. They say some of them are 10,000, but I think that's calibrating the 8,000-year-old date, which is pushing it back too far. But I think some of them are around 9,000. If I remember correctly, these aren't AMS ultrafiltrated dates. So even if you just took the old Vasco material out of, you know, which Probably a lot of it shouldn't be. A lot of it probably should have been repatriated at this point. I'm sure most of it hasn't been. But you take it out of the, museum collection and get permission to date it. I'm sure the dates will get pushed back as it is. Not 14,000 years old, but 10,000 for sure, 11,000 maybe, without any new research.
So I
So-
mean, that you can call a bird, and I think it probably is, but it's not spectacular that way. But it's just the location and where it was and what they think. And they think that it was so well located and protected that it was a common place for trading. They have a trade fair there. Or the other theory on their website is that some religious significance. I'm sure if we go, the guide will have the latest conjecture, but whether that passes.
I mean, I don't, well, no, I'm sure it's fine. I mean, I don't know what we can say about what was happening 8,000 years ago. I think we can probably say a lot about what was happening, 400 years ago, 200 years ago. So that's kind of it, guys. I mean, I just wanted to get us to from point A to point B, and I know it took a long time.
I have a question about this.
Mhm.
So watch where we are here.
Mhm.
The water's going to go up,
Mhm.
up, and then it's going to collect in the valley.
Yeah.
And then it's going to suddenly
Mhm.
break.
Mhm.
I think that is when the Carquinez Strait gives way. That.
Well, why don't you play it again? Is it? I mean, I don't think.
Okay, then my question is, why does all that inland lake go away?
There's potentially there's potentially slightly more drying.
Not much water.
I think the simplest explanation is, well, one, that there wasn't much, we're not talking about very deep water. So you're looking at silting.
Okay.
So you're looking at silting and channeling for the most part. But you also have to remember that when you get there, you're at the mid-Holocene optimum too. So if you play that again and you look at the dates.
It's really terrible.
Oh yeah, I mean, you'll see. So if you look at the dates here. There we go. Okay. Yeah, so this is a mid-Holocene optimum right then.
Okay.
And now 2,000 years ago is too recent, but the maximum extent starts really around 5 to 4,000. So like 4.5 thousand years ago is kind of the end of the mid-Holocene. People cite the mid-Holocene optimum all over the place, depending on where you are.
Right.
But for sure, at 5,000 years before present, like the sea level slightly higher, and you really see that effect in shallow coastal environments. So like I think I showed you some of the pictures in Singapore and Pulau Ubin on the side I was excavating. You can still see, because there are these huge granite exposures on the side of the island, you can still see the high water mark from the mid-Holocene optimum.
Okay.
Yeah. The sea level is slightly higher. I mean, about, oh yeah, they have a huge effect. Yeah, but a lot of this, but most of this is silting. Really, the main process is silting and channeling.
Yeah.
So you're going from a shallow inland, lake or pond, primarily almost all entirely fresh water, to have that silting up as you get more and more of this. And that's one of the reasons why, I mean, really the same, and they don't show it here, really the same process is happening throughout the Tri-Valley and San Ramon Valley. And that's why finding an old like, I'm sure there are old archaeological sites there too. They're just going to be more deeply buried. Does that make sense? So like all of this here and then us in like downtown Walnut Creek is Holocene alluvium. So it's all that process, right? So, you know, as I said, like until, you know, until Santa Monica Valley Creek, Walnut Creek, and Lost Trumpet and Trumpus Creek and all that were canaled and dredged, and you know that was started before, you know, this was part of the United States of America. So that process goes way back. Those valleys would flood during the winter, right? So they'd turn into kind of a marshy kind of wetland.
Are the settlements in those areas lost forever, or can they use sonogram or something to?
Yeah, so the problem is that your deposition is going to be fairly deep. They're not lost forever. It's just like what is going to take you to those sites. So, you know, large construction projects, which is why people, you know, thank God we do have the laws we have on the books that require, you know, if there's a major expansion to 680, they need to do a significant archaeological impact report. My problem with the way some of the reports are done, I mean, that's all part of the environmental impact report stuff, but my problem with the way in which that research is done now is it's done within a thought that we have a very good grasp on what the archaeological record is. So you do a record search. And if the record search comes back negative and you do a pedestrian survey and you don't see anything, then a lot of times they don't even call for monitoring. Like if it's a private construction project, they're probably not going to call for monitoring. If no one's calling for monitoring, then who's going to know, right? And I would say that a lot of the guys, when you actually talk to the construction crews, and a lot of people like to blame them and act like, you know, they're ignorant and they're more conservative and they just want to get the job done. I think a lot of those guys are profoundly curious. You know, they're concerned. They're concerned about not getting their paycheck. They're concerned about getting fired. But I know a lot of guys have stuck their neck out to be like, hey, this is happening, or have archaeological site along the San Juan Valley Creek in Danville, right off of downtown, and that they alerted their foreman, and it was like, shut up, keep digging, keep bulldozing, shut up. You know, and so I'm saying even these guys, they already did their due diligence. Like who else can they talk to? They run across an archaeologist and they go, hey, this happened. You know what I mean? So it's not the construction crew, you know what I mean? But they typically get accused of being the worst of the worst. I mean, the guys in the field, they're not, you know. Sometimes the managers are, the foreman is. Yeah.
You know, everything was going swimmingly there until they excavated and they found human bones in the old shell, which was a common practice.
It was very common. So I'm just going to text Priscilla real quick.
The shell was, and the Native Americans lived on top, but they started burying bodies at the bottom of the shell mound. That shell mound, the huge shell mound, and when Europeans came, I think in the middle of the 1800s, they shaved off the top of it and turned it into an amusement.
Yeah, that's right.
With a merry-go-round.
That's how huge a shell mound was. The amusement park was still there when my granddad was a kid. He told me about it. Showed me some pictures.
Yeah.
There used to be a little trolley too to get up to the top.
Yeah. So it's a hell of a story.
Show is huge.
When they found the human bones, climb out, and it's just what David was saying. They called in the archaeologists, they called in Native Americans because of the respect the burial sites are doing.
Yeah, they're supposed to be afforded. Yeah.
Yeah, and they had this long negotiation that stopped in its tracks the Emeryville shopping center.
It still happened. It shouldn't have. I mean, it shouldn't have happened at all.
Yeah.
I mean, I'll go there. I'll go to the IKEA there, but it should never. I mean, it should never have been allowed.
What you do to assuage your anxiety about that is take some flowers and put it at the memorial of the shell mound, which was what the Native Americans negotiated. Okay. Part of it is you've got to have a memorial, like a cemetery would, and so you go and you find this memorial. I think it's on Shell Mound.
Yeah, Shell Mound Road. Yeah,
and put flowers on it like you go into it, and that's all.
And it just-
Nothing- no mound left.
Well, there's some really like there's potentially and seem to be some really truncated parts of the mound that are underneath parking lots and a few places. And there's a few other mounds as you go up, you know, as you go up 80 into Berkeley that have also been truncated and then leveled effectively. But you know, those mounds are so old that they end up, you know, there's a fair amount of soil formation around them, right? So you can end up with many feet of, you know, particularly in an environment like that, right? You have good soil formation. Think about your backyard, like think about how much work you have to do in your backyard. If you know, for real, like you know how many times you have to like sweep off your porch and do, you know, that's sediment, you know, that's just sediment deposition, but then you get soil formation in it, right? You know, if you pay attention, people always get fascinated by soil formation, but it happens really easily. Like, you know, the joints in the concrete patio, like when you don't clean out, put sand in there and then don't clean out the grass that forms, wait until the next year and all that sand will be brown. That's soil formation. That's carbon injection from the atmosphere, from the plants directly into your sand. That's soil formation. Yeah. Yeah. Oh, thank you. Thank you guys. Yeah. Okay. Good. I'm glad. I'm glad.
I'm gonna stop it.
Yeah.
I'm gonna stop the recording. So, anybody have any?
I do have a question. On the slides going back.
Okay.
With various highs and lows of water.
There.
And no further back, but it was a map of Canada, and it looked like there was a waterway that sort of went up on a diagonal from like Michigan all the way past Alaska.
Where? It would have been maybe this map, like here, like here.
That.
Yeah. So you get these massive glacial lake formations across the northern hemisphere towards the end of the last glacial maximum. There's
Okay, so
tons.
that's just pent up water.
Yeah.
It's not-
Yeah, and a lot of them are held by ice dams. And so you have like the Missoula floods down the Columbia River Gorge, and you can still see the consequences of that, you know, over 10,000 years later. There's sections of the Columbia, you know, River Gorge that are still stripped down to the bedrock, and that's from the Missoula, the series Brits floods and all these other floods and stuff. And
Amazing. Water.
it was, yeah, it's insane.
So,
Yeah, like the old, if I remember correctly, because I had to go out and like, I've done a lot of things that I should have recognized were cool or like more interesting than I realized at the time, because there's just certain things I care about certain times and other things I don't care about, but that doesn't mean that you don't get stuck doing research. So I did, you guys know, like Vancouver, like Vancouver Island and all that. And so, you know, the initial or early Fort Vancouver was in Vancouver, Washington. And so I did do some very minimal, like below ground testing at a section of what would have been the old fort. Are partially built on top of one of the old gravel bars that's left over from the series of floods. But I mean, we're talking about like a huge expanse that's just like this big, huge, you know, gravel bar. And then you got to think, like, if you ever go, which I normally show a slide, I didn't show it to any of you guys as a joke, just to explain how terrible Britain is. But if you go to Britain, and particularly, well, it doesn't matter if you're in East or West Britain, but I lived on the East Coast, and you go to the beach, it's flint. The beaches are covered in flint. That's what they're covered in. It's flint pebbles. And some of them are barely subangular. It's not nice sand. It's like, it's terrible. Yeah, and that's all glacial outwash. That flint is all from Scandinavia. It's from Finland and Norway. You know, so yeah, because when that glacier melted out, it melted out into the channel and it formed a huge lake there as well. and it just filled that whole section, the whole coastline with all of this chert, because a chert's what, you know, what was left over from grinding down and breaking down all this rock from a kilometer of ice being on top of it. And then, you know, the Doggerland area, so like the North Sea coming further down was another large ice dammed lake, and that broke and flooded. Yeah, there's all this crazy stuff. So, you know, right when stuff was getting good, stuff got kind of bad if you were in some places, right? I mean, they seem to be, well, they are disasters on scales we've not seen in the Holocene, but they're still fairly local. By fairly local, you got to think about something that probably dramatically affected the coastline of like all of, or more than, because the lake kind of extended into like eastern Britain, right? But would have impacted, you know, huge sections of that coastline, and probably, I mean, who knows? I mean, maybe made it uninhabitable. I mean, for sure, whoever lived there was freaking dead. But, you know, like maybe left it, yeah, maybe left it uninhabitable for a long time, right? Just because it's so massive that you just have this erosion of most of the surface sediment. When that happens, it just, you have to wait for everything to build back up again. Soil formation, the fauna comes back, the flora comes back, the fauna comes back, and then people can come back, right? So, yeah.
So you said Doggerland, right?
Yeah, Doggerland.
So Doggerland was when the sea level was 300 feet lower.
Or 100, I think 120 or something. Yeah, 120.
So it was a whole land mass that connected Great Britain and Ireland to Europe and Scandinavia. And
yeah, well, Doggerland stayed longer. That's why but then Doggerland is named after the bar. So it's a bar underneath the channel. So it was always known as a place where you could get hung up. And so that was called the Dogger Bar by the Dutch or whatever, or yeah, and that's Doggerland. But then that's what Doggerland got its name from. Or maybe it was Dogger Bar, but I mean, maybe I don't know if Doggers, this is how I really should know. I don't know if Doggers Dutch or Danish. I mean, I should know which language it is, but and I don't remember off the top of my head right now.
Like your bathtub, it changes the way you look at your environment, and it affected our environment where we live.
Yeah,
Amazing.
yeah, for sure. I mean, even if our climate model projections are as bad as they say, like the worst of them, we're not gonna experience a ton, you know, like a huge change, not like this. Like we're not talking about, you know, that massive, but yeah, for sure we'll have coastal inundation, right? You know.
Which is what we had in the home.
Yeah.
The water level.
Yeah, the water levels. I mean, it won't. Yeah, that's for sure. It will be like that. Yeah, it will be like that for sure. I mean, it won't be as dramatic in the Central Valley because again, that's silting and channeling, right?
Yeah.
You know, that's silted and channeled from not having been naturally channeled, right? Do you know what I mean? So like as that's silted in, of course, the water courses have burrowed further down into the ground, right? Rather than having this shallow kind of lake, you know, pelagic kind of whatever system.
Replenish the water table. It's been drained dry recently.
Well, the problem
by the Anthrop.
Yeah, for sure. I mean, maybe. I guess the issue is if it's hot and dry, and you guys, I don't know I know that because whenever you hear these, well, one, I think there are multiple different models that project what's going to happen. And then the media likes to use all of them to be like, it's going to be hot and dry here, and it's going to be hot and wet here, and it's going to be colder there, and you have more extreme this and more extreme that. It's people, I think, synthesizing a lot of different models. So, you know, I'm sure there's a comprehensive model for the San Francisco Bay Area because they're already looking into investment projects for coastal levees and dikes and stuff, right? But, you know, I could imagine that you could potentially have it be hotter and drier here, in which case you're going to adversely affect the water table, right? Because you'll have coastal inundation, which will increase groundwater salinity too. Yeah, and then you'll have a decrease in you'll have actually, you'll still also have an increase in salinity in the inland water table too, just because it will dry up further. Yeah. Yeah.
You have all the money, sponsorship that you could even dream of.
Oh.
What is the most interesting to you? You know, is it here or is it in Asia or wherever?
I think, which is something that I've not even barely published on, but you know, my passion was understanding this, you know, the evolution of behavioral dynamics and social systems called sociality, but between us and Neanderthals and other archaic humans. And for me, I think one of the big issues is research research intensity and like research methods that were used. And I know most people would probably like, and rightfully so, like colleagues would scoff at me and say, well, today people apply the exact same already going into my PhD was that there wasn't any real behavioral difference, any significant behavioral difference between us and Neanderthals. And, you know, during the course of that study, they, you know, learned that, yes, we have Neanderthal alleles. And then, you know, people go and they reappraise certain things that were thought to be maybe bits of art by Neanderthals, but then they've discovered a lot more and people have taken it more seriously. So it's like, here's all this more, you know, this evidence for behavioral. I think behavioral modernity is a bad model of trying to understand human evolution, but it exists. So they find more and more evidence associated with Neanderthals. But for me, my particular interpretation of what happened was when this model of what's called the, you know, the human revolution occurred in the late 70s and 80s and really took off in the 80s and 90s as a dominant model explaining, you know, human evolution. What happened was you had researchers and some really good researchers who went out to these origination sites, these early, what we assumed to be most likely are early modern human sites in Europe. And they re-excavated old sites. So sites that had been excavated even in the 19th century. And so they went back out. There's still enough stratigraphy at a lot of sites. They excavated some new sites, found adjacent sites, and they started doing things that no one would ever have done, like taking mosquito mesh to ultra sift sediment. And when they start doing that, of course, they find a huge amount of evidence for bead use and for more complex use of material and all this stuff. And so the argument becomes, the argument used to be like, yeah, the argument like from the 19th century going into the mid 20th century was the origination is first modern human and in Europe. And they do stuff more complex than Neanderthals do, for sure. And it sets this trajectory towards the later Upper Paleolithic. We have the beautiful cave paintings, we have all this, but they're still pretty primitive. But once people wanted to undo that argument, and then people got funding to go out and start to fine filter, you have to remember in the 19th century, people were digging by hand and pulling stuff out by hand. So they weren't screening stuff, right? You know, you're digging out what you could find in the ground and you're not necessarily digging systematically. So they go out there and they start digging systematically and they start screening systematically. And it's like, not only do we find little fine beads, but we are excavating carefully enough that we can find evidence that suggests like, you know, this is a little bead workshop. Like we can see a discrete zone where people are now grinding down like shell to make little beads, and here's where they're breaking down shell to make, right? And what I would say is that no one has ever really, I mean, this is where all my colleagues would rightfully say you're wrong, but I would say that people still haven't really taken the idea that such things could occur at Neanderthal associated Middle Paleolithic sites as seriously, right? And yes, today people are very careful with how they excavate. That is true, but because they are, now we're finding stuff and people are arguing over it, right? Now we're finding, you know, like there's some incredible stuff at these Neanderthal sites where it's like they are making shell beads and they're re-dyeing them to make old shells look like new shells. Like that's a pretty complex thing, right? But all that stuff was dismissed before because it wasn't found, right? And so what I would love to do if I had all the money in the world is go back out to some of these famous type sites that are type sites that are like named for sure, like whole archaeological sequences, and find adjacent nearby sites or see what's remains of the stratigraphy of some of these things, and just search systematically like that with and because I'm convinced that you would find so much more evidence for complex behavior on the part of Neanderthals if you really set out to do so. And that's always a problem. You should never set out to find one, but I'm just convinced that you could. There's too much stuff already that we know.
So that would mean that there is more contact between Neanderthals and later man. And
No, because even some of the stuff that we have is so much is so early that it's for sure it wouldn't be, in my opinion, it wouldn't be evidence of contact. It would just be evidence that there's convergence of behavior. Either there's convergence of behavior or that some of those symbolic systems go back to the last common ancestor. I mean, I like I said, for me, I think that these archaic hominin communities had language. I don't know if language is always the best explanation to describe why you have systems of demarcation and ornamentation. Like ornamentation is a very strange thing, and it's not necessarily the most. People try to make functional arguments about why ornamentation exists because people still want to fit stuff within an evolutionary framework. And I'm all fine. I'm for sure a neo-Darwinist. Like that's me. But I think you start running into certain things where it's difficult to explain the emergence of certain behaviors in that framework. And so I think because of that, people do want to say, oh, it's contact because it's such a bizarre. They either want to say, yeah, it's a result of contact between Neanderthals and modern humans. You see this stuff with Neanderthals. They either want to say that, or they want to say, it. I don't think it is, but it's still, I think it's more of a puzzle. It's like, doesn't make sense as to why you would have that emerge more than once, but it seems like you do. It seems like you do. It seems like independently, Neanderthals come up with a way of demarcation, through ornamentation, and modern humans do the same thing. I don't know why that would be. But for me, the presence or absence of that, in my assessment, says very little about whether you're human or not. And that's one of the reasons kind of why I'm so passionate about proving that they consistently did this, because I think it would make people have to throw away the traitsless behavioral modernity argument. And I'm passionate about that because it's called human revolution, basically, like the Neolithic revolution before it or after it, right? But before it, chronologically, in the history of archaeology, they came up with the idea of the Neolithic revolution first, and then much later, people came up with this idea of the human revolution. The human revolution argument is got so much press coverage that you would be amazed to see the policymakers, philosophers, scientists in very distant fields from archaeology making a reference to the human revolution argument, right? So like, even when you look at stuff like, I said this before, like, and I brought this up, I think the last time, even looking at things sometimes like major tomes on like international relations, they always need to start with their framework of what it means to be human, because ultimately you're addressing human issues, even if they're on major state players interacting with each other, right? The recourse is still ultimately down to human psychology. And almost regardless of what particular diversified philosophy or paradigm or school of even international relations stuff. I'm just saying it's far away as that they belong to. They'll start with, well, we all know 35,000 years ago, I mean, for real, like I've heard people say this, and I've seen it written in major books you would think would have nothing to do with that. We all know 35,000 years ago is basically the beginning of the human story, and you have this base level of human culture, and that's what makes us human, and that's what it is, and that's your starting line, and that's your this, and it's not, in my opinion, it's baloney. But I think it's dangerous because it takes too many things for granted. It takes too many things for granted. It assumes that too many components of what we find richly rewarding, I think, both in our culture, for sure, and I think in other cultures too, as making our life meaningful. Basically, the argument tells you that they are givens, that they are behaviors like any other species behavior in any other species. I don't have a problem with that concept, that maybe some of these things we think are so culturally important are just behaviorally driven behaviors. That's not my beef. My beef is to come off with such hubris to insist that they are givens, they will always be there. Basically, we don't need to do anything to guarantee that they continue to exist. Yeah. Yeah. I think it's very bad, and I think it leads to a lot of false assumptions about, because if you're using that as your baseline to then assume so much more such hierarchies of complexity, right? Like that's your baseline, and then you're going to build it to like how we should handle Russia and the invasion of the Ukraine, right? Like, while I know that they don't make that argument in an article addressing specifically the Ukraine, these things are brought into the major tomes that are explaining that particular philosophical or paradigm or school of thought within X policy.
Oh, but the realists do.
Well, the realists 100%. Yeah, I'm thinking about the realists in this regard. Yeah. This is exactly what the realists do. And you would be amazed by, I mean, even some kind of postmodern philosophers start that way too. So it's exactly the opposite end, right? Exactly. They still start with this, 35,000 years ago, we know this, and this happened, and you get X, Y, and Z comes along, and that's just what you have. And it's like, I don't think so.
Harold and Carolyn,
Yeah.
I don't know, I don't see Carolyn, but Harold is stuck with us. I wonder if you have any questions, Harold?
I put a question in chat, and the question was, is there any scientific evidence one way or the other whether Neanderthals were capable of speech? Somewhere I thought I read that there was something about the muscles in the throat that somebody analyzed that said that Neanderthals weren't capable of speech, but I'm not sure I understood it correctly.
So as far as, let me just see here, let me just make sure. Okay, so as far as the mechanics are concerned, my assessment is that Neanderthals, and I think the mainstream consensus is that Neanderthals would have been capable of speech. There's always a back and forth.
You froze.
Lack of better words, of the roof of your mouth to where your windpipe meet, and Neanderthals appear to retain a structure that's more common to like modern human juveniles or toddlers and infants. So it would have potentially changed the pitch of their voice. The problem with that is, which is something that I was just had a discussion with my friends today that we recorded for another recording about interdisciplinarity and how a lot of times it's done wrong. And this is an example of where interdisciplinarity should happen and should be done right, which is that while you will get anthropologists almost in the same department who will argue and get a lot of funding to show that the tonal pitch of Neanderthals would have been this range because of this slight difference in the anatomical structure of their throats, as we can reconstruct, you'll get the people who are like more or less doing, you know, feminist or trans anthropology who are doing really good work to show you that vocal pitch and range in humans are far greater than we realize, and that most of these things are culturally determined, right? Like it is actually kind of a given fact that like humans and almost every culture, although size affects this, and obviously our Adam's apple is bigger and therefore our vocal cords are more relaxed, but like in theory, males and females could talk at the same pitch. There's nothing with us in any community that makes it physically impossible for us to talk at the same pitch or to speak at the same pitch and cause vocal damage. Like men could choose to speak a little higher and women could choose to speak a little lower, and you'd have far more overlap without any damage. So these are learned things. So that would be my point. That would be my caveat to it. So while people would say, oh, well, Neanderthals would have sounded so different, we have no idea how any of these other cultures in the past would have chosen to speak, right? You know, and so that would be my argument. So maybe the vocal pitch range was different. It would have overlapped with us a lot. And I would also say that, again, there's a large diversity in that range amongst living people today. And even though there's still a lot of overlap, and yet we seem to culturally decide not to, you know, express overlap. We seem to choose to express difference. Yeah.
Okay, thanks.
Yeah.
All right, so this is great. I want to thank you.
Thank you.
We look forward to our
You got to
next,
get in there a little closer so you can pop up through the jungle.
Yeah, follow me through the jungle. We look fun. Brian and I look forward to our next trek through the open space. Who knows what other doors it will open, but it sure opened a nice door here. So thank you for getting us to Vasco Caves.
Thank you, guys. Thank you, guys. Yeah. Let me see. Oh,
No, it's just one.